Good morning.
Okay, so let's start the second day of the Copernicus Marine General Assembly 2024. So good morning, good afternoon, good evening to all of you. So we have a dense agenda today, this morning. So we'll have the first session dealing with innovation on the user needs and service evolution. Then we will go through the National Collaboration Program on the coastal zone on a conclusion on the post-2024 perspective. So I will now leave the floor to Stéphanie. Stéphanie will moderate the first session on the user needs and service evolution. So Stéphanie, the floor is yours.
Thank you, Pierre-Yves. Good morning, everyone. So my name is Stéphanie Guinehut, and I will chair the first session on innovation, user needs, and service evolution. And we will start with an introductory talk given together with Corinne Derval. And I would like first to thank also Angélique and Valentina who help us to prepare this session. So let's start with the first introductory talk on user needs and service evolution strategy. So the Copernicus Marine Service is a user, policy, science-driven service, continuously evolving service to remain state-of-the-art and a leading service for Copernicus. The continuous improvement approach is applicable to all Copernicus service elements, the production centers, marine data store, web, and service. Copernicus Marine is a user and policy-driven service, which means that user feedbacks, policy needs are monitored and translated into service product evolution objectives, and benefiting from guidance from our champion user advisory group. So Corinne will describe user feedback process and needs more in detail just after this slide. Copernicus Marine Service is also a user-driven service, which means that scientific and technical advances are fully taken into account. And we benefit for that from guidance from our scientific and technical advisory committee. And just after Corinne's talk, I will give a little bit more information on the overall service evolution strategy. So now I leave the floor to Corinne, please.
Thank you, Stéphanie. So good morning, everyone. So I'm Corinne Derval. I'm responsible of the portfolio and stakeholder engagement team at Mercator, and my presentation will focus on the user feedback process we use in Copernicus Marine Service. So Copernicus Marine Service use a user-driven approach to better serve all public and private user communities and support policies related to all marine-related sectors. This feedback process starts by collecting user requirements in terms of ocean products and services across a wide range of communities using surveys and training events, workshop, website, and user support. We collect needs from the policy sectors, as well as from our advisory group, such the champion users, from the Marine Forum, and from the producers themselves. Moreover, collaboration with other Copernicus services and interested entities as well with USPA are also a great source of feedback. All these needs are centralized in a database and posteriorly analyzed to assess, synthesize, and report this requirement in a document called the Copernicus Marine User Feedback Report, which is used yearly and will be published soon on our website. Then internal meetings are held to discuss the technical and scientific feasibilities of these requirements, including discussions with the Scientific and Technical Advisory Committee. If some of these requirements are feasible after a validation, we proceed with the integration and the entry into service of this new product or services. This feedback process is continuously evolving and improving, and it's carried out in a daily basis. As mentioned before, all this feedback collected from all user communities reported and analysis in the Copernicus Marine User Feedback Report. This document was first written in 2022 to synthesize user requirements in terms of products and service, and is now produced yearly. It provides an in-depth look at the methods, sources and tools used to collect user feedback, analyzes user needs, and present the conclusion drawn, as well as the evolution of the service. It includes a specific section for policy needs and recommendations for the service evolution. This report is a key element to ensure that Copernicus Marine meets the needs of most of our users. As I mentioned before, we collect technical and scientific advice from our advisory group, the Champion User Advisory Group, and also from the Marine Forum. This group was formed, as I said, in 2022, and it's composed of 18 independent experts from the public and private sectors. They are selected according to their specific market and marine expertise and their representativeness of the EU member states. They help us to assess if the catalog is fit for purpose for most Copernicus Marine users, advise us on how to improve it by including new products or services, and provide expertise on how the Copernicus Marine data can be used for different applications across several markets and sectors. We meet around twice per year to discuss all these points during workshop and event. To conclude this part, I would like to show you just a few examples of how the feedback contributes to driving the evolution of what is being offered by Copernicus Marine. During the past years, it has been highly requested to provide high-resolution bathymetry, which has been implemented since 2023 using satellite observations. Moreover, to better serve coastal monitoring activities, more and more high-resolution products near the coast have also been requested. As an example of how we respond to this need, this year we will introduce a wind product based on Sentinel-1 SAR observations with a resolution of 1 kilometer that complements our already provided high-resolution products of Sentinel-2. There is also a need to support marine conservation and biodiversity by providing more biogeochemical variables. To address this, we participate in long-term evolution projects, such, for example, Neccton project that will enhance our green ocean offer. And finally, we better serve our users by improving data access to all our products with the new Marine Data Store, already fully operational for a faster and more efficient way to reaching the data the user need. These are just a few examples of how the feedbacks drives our evolution, and therefore we are always eager to hear more from the users. So to conclude, I would like to encourage all of you to go online to our website and fill out the annual survey we recently published to help us to improve. So thank you very much. And Stéphanie, the floor is yours.
Thank you very much, Corinne. So now I will give you more information on the overall service evolution strategy. So Copernicus Marine service evolution strategy is built with the support of our STAC, Scientific and Technical Advisory Committee, composed of 12 independent international experts, which are listed here. And Neville, his chair, will give a few words at the end of the session. As it has been mentioned yesterday, this advisory committee is complemented by observers coming from other Copernicus services, but also from ESA, EUMETSAT, and Euroguz to foster the communication between those different entities and the Copernicus Marine Service. The service evolution strategy is fully described in this document, which is available online. It has been prepared by the STAC, and it's regularly updated. In this document, we have defined 8 overarching R&D themes for the evolution of the service. The main R&D priorities cover the next generation of integrated ocean forecasting systems, high-resolution monitoring and forecasting of the blue ocean, the Arctic Ocean, including sea ice analysis, modeling, and forecasting, machine learning, AI, big data, high-level data products, as well as ocean climate products, indicators, and projections, space and in-situ observations, and impact studies, biogeochemistry and marine biology, as well as the marine coastal environment. To best organize the service, as it has been already mentioned yesterday, we have defined 3 streams with different time horizon, players, actors, and funding mechanisms. So they are listed on this figure, and their main common objective is the integration of the development in the operational system. The first stream corresponds to Tier 1 short-term activities. They are addressed within Copernicus Marine through production centers activities, so our TAC and MFCs, and result in regular update of the catalog. So you had a complete overview yesterday of all the evolution that have been provided or which are foreseen. And these evolutions are managed through a research to operation process with a series of formal reviews, starting even 2 years in advance with a specification review, then going to design and acceptance review before the evolution is finally implemented in the catalog. The second stream, or Tier 2, corresponds to the midterm evolution. Those are addressed within Copernicus Marine both through production centers activities, but also open R&D service evolution calls. These calls cover targeted topics defined in the Copernicus Marine Service Evolution Strategy R&D priority document just mentioned. And those projects, their objective is really to obtain significant results in less than 2 years, with the potential of concretely improving the operational service in the following year. And for this project, we have a strong coordination with our production centers to foster the uptake of those results. During Copernicus 1, we had about 30 projects which have been funded through R&D calls, and their summary and main outcomes are available on the Copernicus Marine website. In Copernicus 2, we launched a first call in January 2022 and selected 14 projects. Those projects started in July 2022 and will end very soon in August this year. Uptake in Copernicus Marine is planned in the following years. Again, the summary of all those projects are available on the Copernicus Marine website, and the outcomes will be published in the coming weeks. So we have some projects dealing with new improved products for high resolution, multi-resolution coastal ocean color product coming from Sentinel-2 and 3 with the MultiRes project. We have the COSI project dealing with particulate and organic surface products, particulate dissolved organic carbon at the surface for coastal and global ocean. We have a project dealing with long-time series of phytoplankton functional type, which is called GLOPHITS, and another one for the detection of Sargassum algae, which is called SODA. Then we have ocean mass from Grace and freshwater fluxes with the Wombo project. Two projects, slicing and Faudet-Varnet, dealing with next generation of sea level products, and the ADEOS project dealing with ocean surface current from IES data. Then we have a series of projects dealing with upgrading, preparing the next generation of operational system, including advanced data assimilation methodologies, ensemble-based, multi-grid with the Odessa and Multicast project. We have COSI dealing with the calibration of sea ice forecasts. And then we have three projects dealing with the coastal zone monitoring, including river-ocean interface, wave modeling, and risk assessments with EstuarIO, Kelani, and coastal risk. Four of these projects will be presented just after during this session. And just to mention that the second call has been issued in January this year. It is under evaluation, and new projects should start during the summer. So finally, we have the third stream of Tier 3 for the long-term evolutions. Those are required to prepare major evolution of the system for the coastal, Arctic, marine biology, ocean climates, and digital services. They are addressed externally with specific projects. We strong links with Horizon Europe project, dedicated Horizon Copernicus Marine evolution calls, but also projects funded by space agencies such as ESA, EUMETSAT, or national projects. And again, those required high-level coordination to prepare and ensure an efficient uptake. So I've listed on the slide a few projects, but there are many more, and 5 of them will be presented later during this session. So here, this is my last slide, just to mention that the Earth Observation Strategic Research and Innovation Agenda document is now available online. This document has been prepared by the European Commission together with Copernicus interested entities and agencies, and it served as a reference for calls in Horizon Europe for this for the next work program, but also as an initial preparation for the subsequent framework program. You have the full information on the documents, but here I've listed the main priority topics for the Copernicus Marine Service, and it includes marine data assimilation techniques, the Arctic Ocean, artificial intelligence methods, downscaling capacity, carbon modeling and data assimilation, seasonal forecast of marine environment changes from global to regional scale, prediction, detection, and attribution of extreme events. So with this last slide, I finish with the introductory presentation, and we will now move on to the next item on the agenda with this main result from service evolution R&D project. So given the allocated time, we have asked 4 projects to present their main results. And before going to the first presentation, I just wanted to remind you of the Q&A facilities that is available on the main website. So if you have questions, please go to the Q&A button. So I will now leave the floor to Cyril, And for all presenters, please try to stick into the 10 minutes allocated time. And just to let you know, when I will be back on the Zoom, it will mean that you will have 2 minutes left to present your project. So now I will try last time to give control to Cyril, but no, we can't see you, so I will pass the slides for you, Cyril.
Okay, that's fine. Yeah. Yeah. Okay. Thank you very much. So I'm Cyril Palerme from the Norwegian Meteorological Institute, and I'm going to present the COSI project. Yeah. Next slide, please. So COSI has been a collaboration between researchers from the Norwegian Meteorological Institute in Oslo and researchers from the Nansen Environmental and Remote Sensing Center in Bergen. And yeah, the different researchers who contributed to the project are shown on this introductory slide. Yeah, next slide, please. So in weather forecasting, it's usually we use a numerical weather prediction system to produce weather forecast. And for the most important variable for end users, such as precipitation, temperature, and wind, it's very common to apply a post-processing calibration step, which consists of a statistical correction of the weather forecast produced by the numerical weather prediction system. So this allows to reduce the biases of the forecast and to improve the accuracy. However, this post-processing calibration step is not common at all in short-term sea ice forecasting, while sea ice forecasts have considerable biases following spatiotemporal patterns, and that machine learning is actually quite suitable for correcting forecast biases. So the idea of the project has been to develop post-processing method based on machine learning. Yeah, next slide, please. In addition, we tried to take into account the user needs, and from 2017, there is the International Code for Ships Operating in Polar Waters, which states that ship crews planning to navigate in areas with a risk of sea ice concentration higher than 10% must acquire sea ice information before their journeys, and there are different requirements for ships operating in areas with a sea ice concentration between 10 and 20% and higher than 20%. So in COSI, we propose to improve the accuracy of deterministic sea ice concentration forecast using post-processing, but also to develop forecasts for a variable that we call the sea ice probability, which is the probability that the sea ice concentration exceed either 10 or 20% for the sea ice concentration, so in agreement with the Polar Code requirement. Yeah, next slide. Then we decided to post-process sea ice concentration forecast from the TOPAZ prediction system. And we use supervised machine learning, meaning that we need a dataset for the target variable, and we want a dataset which is at least at the same spatial resolution as the forecast that we want to post-process. So in COSI, we post-process the forecast from TOPAZ 4, which are at 12.5 kilometer resolution. But we have also the goal to post-process the TOPAZ 5 forecast, which are at 6.25 kilometer resolution. So one work package of the project has been dedicated to the development of new satellite sea ice concentration observation at 5 kilometer resolution using data from the AMSOR2 sensor. So the figure here shows actually like an example of these observations. Yeah, next slide. So we use this new AMSOR2 observations for the target variable of some deep learning model. And then we use a set of predictors, which are shown on the left part of the figure. So we used also AMSOR2 sea ice concentration observation before the forecast start date. So the sea ice concentration observation during the day before the forecast start date, and the trend in sea ice concentration over the previous 5 days. We also used sea ice forecast from TOPAZ 4 for the sea ice concentration, weather forecast from ECMWF for the 2-meter temperature and the wind, and a land sea mask. And then we developed a machine learning model with an attention residue UNet architecture, which contains about 39 million parameters. We use the mean squared error for the loss function. We use 8 years for training the model, so the period from 2013 to 2020. We use 2021 for tuning the hyperparameters of the model, and 2022 for the final validation of the model. So training the deep learning models takes about 3 hours on the GPU. But then once the model are trained, predicting the CIS concentration for the next 10 days takes about 4 minutes. And most of these 4 minutes actually consist of like creating the predictors on the same grid. Because then the prediction from the deep learning model is actually very fast. It takes just a few seconds to produce the forecast once the predictors are created. Yeah, next slide. Next slide, please. Yeah, so how do the deep learning forecasts look like? So here is an example of a forecast starting the 1st of July 2022. What we see is that there is progressively a smoothing which occurs on this forecast, which is quite common with machine learning model trained with the mean squared error for the loss function. But it also shows in a way the growing uncertainty of the forecast. Yeah, next slide. Then we decided to evaluate a bit how the forecast perform. And here is a case study showing, so the two maps on the left shows the AMSOR2 CIS concentration observation during the 26th of October 2022 and during the 21st of October 2022. And if you compare these two maps, what you see is that actually there was an increase in the CIS extent around New Siberian Island, so in the Baffin Bay. Between these 2 days. And now if you look at the Topaz 4 forecast, you can see that Topaz 4 was able to reproduce to some extent an increase in the CIS extent around New Siberian Island, so in the Laptev Sea and East Siberian Sea, but not in the Baffin Bay, while the deep learning model was actually able to reproduce the increase in the CIS extent in the Baffin Bay, and actually it was also able to better reproduce the increase in the CIS extent around New Siberian Island. Yeah, next slide. So then we evaluated the deep learning model during a period of 1 year. It was 2022. And here, this figure shows the root mean square error for the CIS concentration. And what you see is that actually the deep learning model clearly outperformed both Topaz 4 forecast, but also persistence of AMSOR2 CIS concentration observations for all lead time from 1 to 10 days. So on average, the root mean square error is from the deep learning model is 41% lower than from Topaz 4, between 28 and 62% depending on lead time, and 29% lower than from persistence of AMSOR2 satellite observations. Yeah, next slide. So we also developed a probabilistic forecast for the ice edge, what we call the CIS probability. And here it's actually an evaluation of this probabilistic forecast of the ice edge position. And this figure shows the mean distance between the forecasted ice edge and the observed ice edge. And what we see is that here the deep learning model performs also pretty well. So on average, the error for the ice edge position is from the deep learning model is 57% lower than from Topaz 4 forecast and 49% lower than from persistence of AMSOR2 satellite observations. Yeah, next slide. Then we also evaluated how the deep learning model perform depending on the season. So here it's for the deterministic CIS concentration forecast. And what you see is that actually the deep learning model performed pretty well for all the months. So we have quite a significant improvement compared to both Topaz 4 and persistence of the satellite observation for all the months and for all lead time. Yeah, next slide. Then we also evaluated the spatial variability in the performance of the deep learning model. So the top row here shows actually the root mean square error of the CIS concentration from the deep learning model for like 1 day, 5 day, and 9 day lead time. And then we have the root mean square error improvement compared to Topaz 4 on the second row. So when it's blue, it means that the deep learning model outperforms the Topaz 4 forecast. And what you see is that actually the deep learning model outperformed Topaz 4 forecast almost everywhere in the Arctic, with larger improvement for short lead time than for longer lead time. And now if you look at the root mean square improvement compared to persistence of AMSOR2 observations, what we see is that actually the deep learning model outperformed persistence almost everywhere in the Arctic for lead time longer than 1 day. But for one day lead time, you can see that there is a region actually in the Central Arctic where persistence of AMSOR2 observation work a bit better than the deep learning model. But now if you look at the top row, you can also see that this is an area with a very low root mean square error actually in the deep learning forecast. So this doesn't this doesn't represent large errors in this area. Yeah, next slide. Next, yeah. And then it's my last slide about the potential outcome for the Copernicus Marine service. So the production of Topaz 4 has been stopped in April 2024, which means that we haven't been able to develop an operational product during the project. However, we plan to do the same thing for the Topaz 5 forecast, but we need a certain number of forecasts to do it, to train neural networks which are tailored to the Topaz 5 prediction system. And we think that we need at least 2 years of forecast for doing that. So we plan to develop similar post-processing method for Topaz 5, but probably in 2026, 2027. We also developed a method for predicting new variables, so the CIS probabilities, the probabilities that the CIS concentration exceeds 10 and 20% for the CIS concentration, which are actually variables which are interesting for end users and which are in agreement with the Polar Code requirement. And then we shared the method that we developed in COSI in the final report of the project and in a scientific paper, and the code are also publicly available on GitHub, which means that if other people want to develop similar application for other products, they can see what we have done and use it as a starting point. And yeah, thanks for your attention.
Thank you very much, Cyril, for this very comprehensive presentation. So now we will move to the next speaker. Trying to pass on the next slide, yes. So the next speaker is Giorgia Verri, who will present the EstuarIO project. So Giorgia, I will try to give you the control of the slide. So you should have the control now.
Yeah, thanks.
So the floor is yours, please.
Thank you. Good morning, everybody. So I'm Giorgia Verri, researcher at CMCC Foundation, and I'm going to tell you something about the EstuarIO Copernicus Evolution Project. Here you can see all the names of the colleagues who participate to the working group. They are modelers, experimental scientists, computer scientists, belonging to 5 institutes, CMCC, which is the project leader, and then University of Calabria, CLS, CNR Stima, and University of Bologna. So, okay. The objective of the project, there is a general aim. Sorry, I need to come back. Okay, here. The aim of the EstuarIO project is to provide a better representation of the river release within the Mediterranean Black Sea forecasting system, which are within the Copernicus Marine services, which means that we then expect to improve the representation of the circulation dynamics from coastal scale up to basin scale for both marginal seas. In addition to specific goals that have been achieved are the release of an estuary box model tool, which merges machine learning algorithm with the physically based equations, which has then been coupled with the 2 Copernicus MFCs for the Southern European seas, Mediterranean Black Seas. Second specific objective, the release of a tailored EBM. So we expect that this EBM is tailored for the rivers that have been identified as target rivers within EstuarIO, and they are the Rhone, Ebro, and Po rivers within the Mediterranean Sea, Danube River for the Black Sea. This was made possible, it was not trivial, it was made possible by merging with 3D finite element modeling of the river sea continuum and by exploiting the very high resolution EO satellite observation for the estuarine area. I will show you how we achieved these goals. So first, the estuary box model, which is a low complexity model, which has been designed with a specific aim, which is to fill the gap between hydrology models and ocean models working at mesoscale, which means that the model, these models basically cannot solve the estuarine areas because of numerical and geometric constraints. And the simple geometry assumption are that we consider a two-layer rectangular box representing the estuarine areas with constant width but time-dependent depth and length. And there are only two open cross-sections considered at the estuary head and at the estuary mouth. The three versions of this estuary box model have been designed and released. The first one is a fully physically based model. Then there was a second hybrid model developed, and the final one was a fully machine learning based box model. Without going into details, I want just to mention what are the required inputs and what are the expected outputs of the estuary box model. So what basically the box model needs as input fields are volume flux and tracers at the head of the estuary, where tracers are temperature and salinity is expected to be 0 at the head of the estuary, and similarly volume flux, temperature and salinity at the river mouth. What the model is able to release at output fields are the net outflow at the river mouth in terms of volume flux exiting the estuary box at the river mouth, but also salinity and temperature. In addition, there are two output fields that can be estimated, which are the length of the salt wedge intrusion, which is basically the estuary length, and then the long estuary mixing coefficient. So we work with the three versions of this code. We compare the performance. So what you can see in these panels are the performance of the three code versions with respect to capability to estimate the salinity at the Podigoro river mouth, which is one of the branches of the Po Delta system. And what this was a quite lucky test case because we can rely on in situ observations of salinity, and we could compare and evaluate the performance of the different approaches. At the end, what we found is that the machine learning based approach outperformed the physically based one. Similarly, if we look at the length of the salt wedge intrusion for all the branches of the Po Delta system, which is another output field of DBM, again, the machine learning approach is found to overcome the physically based one. So we decide also to push the capability of the estuary box model, trying also to provide a salinity forecast by using a deep learning algorithm, which is the long short-term memory algorithm. And basically, three schema of this deep learning algorithm have been designed and trained, and we compare the performance of them looking at one step ahead forecast, which is represented by the three panel on the top line, up to 7 step ahead forecast of salinity, which is represented by the three panels on the bottom line. So the three configuration basically combine in different way the number of the previous input time step entering the algorithm and the number of features predictors entering the algorithm. And what we found is that and it is reported in the green boxes, we were able to distinguish which configuration perform better when we look at 1 step ahead forecast or up to 7 step ahead forecast. Okay, the estuary box model need a quite complex, demanding training phases in order to calibrate the physics-based equation or to train the machine learning algorithm. For this reason, we decided to use a merged strategy, which means that we introduce a 3D finite element modeling of the river-sea continuum for the target rivers, and we basically exploit the results of this 3D abstraction structure grid models in order to create a learning data set to be used for the training and testing phases of the 1D box model. So for our 4 target rivers, we set up an experimental configuration of the SHIFEM structure grid model over the river sea continuum for each of them, and we force our multi-year experiment, multi-year historical run with the available reanalysis in order to get results we can trust as representative of the real world, a sort of digital twin for our target areas. There are few observations available in the estuarine areas, so we focus on the ones that we were able to identify, and we validated the results of our 3D models in order to trust our results and use them as learning data sets. So I put here some of the validations that have been performed. So in addition to using the 3D modeling of the river sea continuum, another added value came out by properly exploiting the EO satellite observations with very high resolution in the coastal areas. They allow basically us to retrieve the riverbed depth for Rhone and Danube rivers, since we couldn't rely on in situ surveys, and images of reflectance from Sentinel-2 with Landsat 8 with tens of meters resolution have been used to and processed within a band ratio algorithm, which basically provided at the end an estimate of the actual riverbed depth. So this allows us basically to set up our 3D model of the river sea continuum where bathymetry was unknown. And similarly, the satellite very high resolution observation coming from Sentinel-2 have been exploited for retrieving river mouth tracers in terms of temperature and salinity. Here you can see a couple of pictures showing the surface temperature at 2 river mouth, the Danube Sulina mouth and the Grand Rhone mouth. The green time series show the modeled surface temperature provided by the estuary box model, while the blue dots refer to the data that derived from the optimal remote sensing from Sentinel-2 and Landsat 8. So at the end, we found a quite good agreement. Similarly, we look at the Sentinel-2 multiband reflectance in order to retrieve the river mouth salinity to support our training and testing phases of DBM. This was a bit more tricky with respect to the surface temperature, as salinity has not optical properties. So what we did, we use the images of reflectance in multibands to feed the neural network, where at the end 3 ocean color measurements have been released. Among them, we identify CDOM, the color dissolved organic matter, as the one showing a good correlation with the salinity. So CDOM was considered basically as a proxy of salinity. And so far, we identify a correlation relationship between CDOM and salinity for the Po Delta mouth. The work is still ongoing for the other target rivers of the EstuarIO project. In any case, this is an additional data set that can be used besides in situ data to train and test our results in the estuarine areas. Moving to the very final goal of our project, which was basically to improve the representation of the river release within the MFCs for the Southern European seas, what we did, we performed a set of experiments in order to evaluate the additional value of using the estuary box model coupled with the 2 Copernicus forecasting systems. And a set of experiments has been performed. Here I'm going to show you the results results we got for the Black Sea forecasting system. Similar results have been collected for the Mediterranean Sea forecasting system. So as a first, a control run has been considered, which is basically an historical multi-year run using the same experimental configuration as the Black Sea operational forecasting system, including also the way river release enter currently the Black Sea MFCs, which means that except for the Danube, which is based on observed runoff, climatological runoff is considered for all rivers, and constant values of salinity are considered for all rivers ending into the Black Sea. In addition to the control run, 2 sensitivity runs have been performed. In the first of the 2, we consider the river discharge and salinity provided by the estuary box model for all the Danube mouth instead of the classical approach used within the operational forecasting system. In the second sensitivity run, also the river temperature provided by the EBM has been included in the coupling between EBM and the Black Sea forecasting system. So here you can see a focus in the panels on the right side. You see a focus on the region of freshwater influence of the Danube mouth, and picture refer to a seasonal surface salinity. The benchmark considering on the left are the available reanalyses. On the right, you can see the panel referring to the set of 3 experiments and the relative bias. So basically, what we found is that the Black Sea forecasting system benefit from the coupling with the estuary box model, and the capability to represent the Danube river plume improves when we use a couple approach with an EBM, so a better representation, a more reasonable representation of the river release within the Black Sea. Similarly, we perform an evaluation of the sea surface temperature, and again, using a couple approach between EBM and the Copernicus MFCs for the Black Sea. The negative bias that we observe in our control run by comparing with the satellite reduce when we perform the sensitivity experiments using the coupling with the estuary box model. In addition to this comparison, which was based on satellite but with a quite low horizontal resolution, if you look at the green frame, the green frame on bottom left, you can see the comparison with very high resolution Sentinel-2 surface temperature at the mouth of Cilia, where the 3 experiments are represented in green, violet, and red lines. And again, the satellite is provided by blue bottoms. And again, the sensitivity showed that the coupling allowed to improve the agreement between couple model system and the available observation. So to conclude, some messages to wrap up what we found, what are the main outcomes of the EstuarIO project. An intermediate complexity estuary box model was released. This is a flexible and powerful tool to estimate river release and salt wedge intrusion for both forecast purposes and climate purposes. A learning data set has been built with 3D and structural modeling of the river sea continuum in order to get to get enough data to support training and testing phases of the EBM. The machine learning version of the estuary box model is found to outperform the physically based one. And thinking of the CMEMS MFCs, we found that the 2 ones for the South European seas benefit from using an estuary box model upstream of their river mouth to better represent the river release. Last but not least, the exploitation of the satellite observation with a very high resolution in the estuarine areas is found to be a promising bring additional way to monitor the estuarine areas and to support training and testing of estuary box models. Some plans for future is to create a relocatable estuary box model by exploiting machine learning clustering techniques. And second objective is for the future is to get a two-way online coupling between ABM and the two MFCs for the Southern European Sea. So far, the two-way coupling is still offline. And finally, a comprehensive evaluation of the satellite sea surface salinity in the estuarine areas is among the plan. It could need additional efforts, but it seems to be quite promising. Thank you.
Thank you very much, Giorgia. So we now go to the next presentation, which will be by Aida on the MultiRes project. So please, Aida, the floor is yours, and I will pass the slides for you.
Yes, okay, thank you. Thank you, Stephanie. Okay, so yeah, my name is Aida de la Carate. I work at the University of Liège. And in this MultiRes project, I've been working with people of the Arvins Institute, including the co-PI Dimitri van der Zande. You can go to the next slide, please. So coastal regions are very dynamic, both in time and in space. And well, we need appropriate products to monitor this variability. The good news is that we have satellite data, which really measure at really high spatial resolution, temporal resolution. But the bad news is that there is no single data stream that provides us this both spatial and temporal resolutions that are needed in these regions. So for example, you have Sentinel-2, who have a resolution of up to 10 meters, but that only cover a region once every 3 to 5 days. And then we have Sentinel-3, which have up to 300-meter resolutions, and that they go daily over a region. So in order to be able to monitor these regions at both high spatial and temporal resolution, we will need to work with these data streams in a synergy. For that, MultiRes aims to develop a super resolution approach to derive these products. But what we need to do before developing this super resolution approach is to make sure that both data streams, Sentinel-2 and Sentinel-3, are as coherent as possible. So in order to really make them coherent and providing the same kind of information with no biases. So the part of the data harmonization is really important for that. So yeah, the part of the data harmonization, data preparation is an important one. And we have been working, thank you, so the slides go along, that's good. We have been working on the Copernicus Marine high resolution processing chain, in which we have been generating this coherent Sentinel-2 and Sentinel-3 ocean color products to derive chlorophyll, suspended particulate matter, and turbidity. This is a multi-algorithm approach that is guided by optical water types. Depending on which water type we can use different algorithms. We are also adapting the atmospheric corrections and so on, so that the chain is unique for both data streams, and they provide, as I said, the most coherent data set as possible. Now in the next slide, even doing that, we still have some differences, especially in regions in which water are complex. So at Arvins, we've developed a machine learning approach to increase the coherency between these two datasets, Sentinel-2 and Sentinel-3. This machine learning approach is based on a gradient boosted decision tree. And it trains an algorithm to mimic a target data set and taking into account differences in spectral bands, the difference in spatial resolutions, differences in atmospheric corrections, and so on. So the target product, the one we aim to obtain as to have as a reference, will also change depending on the region we are working. So if you go to the next slide, please. We have here two examples of this machine learning correction of Sentinel-2 and Sentinel-3. On the left is the Belgian coastal zone. You can see the Sentinel-2 RGB data, the target product in the top right, which is the OSPAR in this region for chlorophyll. You can see that the resolution is coarse, it's 1 kilometer. And then the two bottom panels are the Sentinel-2 and Sentinel-3 corrected through the machine learning approach so that they are really as coherent as possible. The scatter plots really show that we are doing a good job in here. On the right part of the slide, there is an example of the Venice Lagoon. Here, the target is the OC4met chlorophyll product. And again, you can see how the Sentinel-2 and Sentinel-3 products are able to mimic the target product, but at their own spatial resolution. So 300 meters for Sentinel-3, 10 meters for Sentinel-2. So that's, in the next slide, we can also see, again, an example of this. So you can click 3 times, 1, 2, and 3. And here we see again for the coastal region of Belgium, the target product at 1 kilometer, so OSPAR. You see the low resolution and that the coastal regions are not very well covered. Then the middle panel shows the OSPAR, the Sentinel-3 product at 300 meter resolution, adapted so that it really presents the values of the main values of the target product, and in the right the Sentinel-2, which is much higher resolution and that covers really up to the coast, and we can see much finer details. So these Sentinel-3 and Sentinel-2, so middle and right panels, are the ones that we are going to use to merge them and obtain a single product that will have a super resolution. So you can go to the next slide. I forgot. So we have been validating all this product, of course. This slide shows in situ data from the Pantir station in the coastal Belgian zone in green for turbidity and chlorophyll. And you can see the high temporal variability that this region has. And the yellow line shows what we are able to achieve with Sentinel-2 data. So Sentinel-2 has high spatial resolution, but temporal resolution is not very good. And we can see that here, so that we are really missing all this temporal variability that we can observe in situ. So this is when we use only Sentinel-2 data. Now, so to the next slide. These products then, so Sentinel-2, Sentinel-3 will be used to generate a unique super resolution data set. For that, we will use DNOF, a technique that has been developed here at the University of Liège, and that is used to fill missing data. We don't have to forget that Sentinel-3, Sentinel-2 measure indivisible, they are affected by the presence of clouds. So in addition of merging them, we need also to get rid of the clouds. So that will be done with DNOF. It's a technique to reconstruct this missing data. And when we use both data streams, Sentinel-2, Sentinel-3, we are able to have the EOFs extract the spatial resolution of the data and infer them into the final resolution. So the DNOF will be used to merge these two data streams. The animation here shows just Sentinel-3 dataset SPM. So I will just go to the results. Next slide. Here we can see Sentinel-2 and Sentinel-3 data after they have gone through this super resolution approach. In fact, the labels are reversed, sorry. So in the left, we have Sentinel-3 data. And so the initial data, cloud data, are in the top left panel, and then the reconstruction by DNOF is shown in the right panel of the left side. it's a bit complex. And then there is a north-south transect, which is shown in the panel below. In the panel below, you see this blue line is the initial data, and this is Sentinel-3, as I said, so you can see the step-like, so the pixels, the coarse resolution data, and then our super resolution, which is the black line in this bottom panel, which has a higher spatial resolution, is able to really remove this effect of the pixelization of Sentinel-3. And then on the right part, we have Sentinel-2, which shows the initial data, the reconstruction, and in the bottom panel, this transect, which shows that we are still able to retain most of the spatial variability of the Sentinel-2 data. The top panels don't really help to appreciate how well we are doing in space. So in the next slide, we have a zoom into these regions, this one. So the top panel shows us initially Sentinel-2 data and our super resolution, which still retains most of the variability. The bottom lines show an initially Sentinel-3 data, coarse data set, so you can see the pixels and how the DNOF super resolution is able to remove that and provide a higher spatial variability data set. Next slide. We have done this in several regions. I have only shown the Ostende region, the Belgian coastal zone, but we have also worked in Venice, Gironde estuary, and the Baltic Sea for both chlorophyll and turbidity. Next slide. Now you remember this slide, which was the validation of the Sentinel-2 data stream. If we add now this super resolution data set that we have done, we have this one. So if you can just, Stephanie, go back and forth a couple of times so that we can really see what the addition of this product could do in terms of the temporal variability. We are able to much better reproduce what we are observing on site. So I think we are really gaining a lot by adding this super resolution. So next slide, please. In the left, we can see what is now available in the Copernicus Marine service, so this Sentinel-2 dataset, and in the right panel is what we will propose to now provide this merged Sentinel-2 and Sentinel-3 datasets. So last slide. That's the conclusions. Two main messages. The way we treat the data before any analysis is really crucial. We really need to homogenize everything so that we will have the highest quality possible data sets. So that's very important. And we have shown that with DNOF, we can obtain these super resolution products to monitor coastal waters. We have published this in the two references below. So yeah, if there's any question, I'd be happy to answer. Thank you.
Thank you very much, Aida. So again, if you have any question, please submit them via the Q&A tab on the main website. So now we will go to the next presentation with Marion Sutton, who will present main results from the SODA project. So Marion, I will try to give you the control. So now you should have the control of the slides.
Okay, thank you, Stéphanie. Good morning, everyone. So I am Marion Sutton, working at CLS on the Sargassum topic, project leader on this topic. And I will now present to you the main result or an overview of the SODA project that was part of this set of Copernicus service evolution. So the SODA is about Sargassum operational detection algorithm. For this, we partnered with EGEOS on specific algorithms. So we were two partners in the project, CLS and EGEOS. First, I will give you a bit of context on the Sargassum for those who don't know what is Sargassum. So Sargassum is a brown pelagic algae that we find in the Atlantic Ocean. Actually, the first sight of Sargassum was reported by Christopher Columbus in 1492 in the Sargasso Sea while crossing the Atlantic to discover America. And now in more recent days, scientists reported an anomaly in the North Atlantic circulation in the winter 2009 and 2010. And they believe that this was the cause of the Sargassum escaping from this Sargasso Sea and starting to arrive massively on the wider Caribbean region and West African country. First time was in 2011, and since then, we see that the sargassum influxes in the Caribbean are becoming a new normal with this new area formed as the Great Atlantic Sargassum Belt, providing now a new source of sargassum in the Atlantic. So the problem with this sargassum is that it has actually a lot of impacts, societal, economical, and environmental impacts on the local community. Just to give some example on different stakeholders impacted by the sargassum. So the public authorities who have the mandates in public beach management and public health management are in charge of cleaning the beaches and monitor the H2S concentration. To give you some figures, in 2018, which was the worst year of sargassum stranding in the Caribbean, it was estimated at $120 million, the cost of cleaning the beaches and the sargassum in the Caribbean. The tourism sector is also very much impacted, and tourism is the key source of revenue for most countries in the Caribbean. And sargassum ruins the visual aspect of beaches and impacts on nautical activities. It has also been reported that after a sargassum event, the visitors don't continue to not go to the tourist area after 12 months after the event. So it has a long-term impact. And on fisheries, which is also pretty much impacted, fishermen are hampered by floating sargassum, and especially net fishing. Fishermen can be trapped in ports by sargassum and prevented from going out fishing. And 60% of the fishermen reported a reduction on the fish catch during a sargassum event. So there's a clear and urgent need to monitor the floating sargassum on the tropical and the Atlantic Ocean. And for this, satellite is a key tool to monitor the floating sargassum. The way to do that is to apply an automated sargassum detection algorithm on the reflectance of the satellite signal. The first work on this were done by WHO in 2009, so developing a floating algae index. And now since 2018, at CLS, we have been developing this operational system to operationally process the 8 satellite sensors to produce some satellite detection of sargassum. So the SODA project was particularly targeting this operational algorithm and improving this operational algorithm for sargassum detection on several sensors. So on heliosynchronous satellites, which are the MODIS sensor on board Aqua, the OC sensor on board Sentinel-3 and B, MSI on board Sentinel-2, and OLI on board Landsat 8 and 9, and completed by a geostationary sensor, which is ABI on board GOES 16. So why are we using all these sensors to produce sargassum detection data? There is a clear complementarity of sensors. And as we saw in the previous presentation, so the optical sensors are pretty much impacted by cloud cover. So it's also important to get more sensors to have a better view of the situation and to see between the clouds. And also these different sensors have different pixel resolution, different time resolution, time of passage, sensitivity to cloud. So on the top left, you see, well, on these images, you see the same sargassum structure as it is seen by satellite. On the top left, so you have the sargassum structure seen by Sentinel-2 at 20-meter resolution. But the problem, as mentioned before, it was Sentinel-2 is only passing over one area every 2 to 3 days, so we don't get too much images from Sentinel-2. In the central, you have the same structure seen by Sentinel-3 at 300-meter pixel resolution, and we can get this type of images daily. And finally, on the right, bottom right, the same Sargassum structure seen by the GOES-16 sensor at 1 kilometer resolution. And the advantage of this geostationary sensor is that it takes images every 10 minutes. And so we can build a daily average from this and remove most of impact of the cloud cover. So the first set of tasks in the SODA project, and I will not give too much scientific details, I'm afraid, on this presentation, but we worked on improving all these monosensors projects. We targeted specific effects that was creating or that are creating false detection of sargassum. For example, we worked on the sun glint effect, which is the sun reflection affecting the satellite signal and causing the sargassum to be invisible in the contamination due to the sun. So this work was done on the OLSI and MODIS sensor. We also worked specifically on what we called adjacency effect, which is actually a reflection of the vegetation in coastal areas that creates false strong signal in the signal, and that creates false alarms on the sargassum detection. And also working on reducing the noise on the MSC products. So after this first task of improving the monosensor products, our final goal in the project was to try to merge these images to produce a multi-sensor product. So as mentioned before, the problematic is trying to merge different sensors at different resolution, time of passage, to detect one particular event. And you see on the bottom left, so one situation, again, seen by the three different types of sensors. In yellow, you have the Sentinel-3 detection of sargassum, seen at 1 o'clock at local time, and the same structure, possibly the same structure on the same day seen by MODIS at 5 years later, and this daily average of images from GOES at the background on the background color. So the problematic is really to understand how we can identify similar sargassum mats in different images and try to combine them and to produce one daily images. So for this, we tried different methods, and we worked on using drift modeling with the Copernicus current model, trying to drift, to propagate one observation from one image to the other. So we have some first results, and it was promising results, but it was only done for some tests, as you can see on the bottom right, to try to really identify, thanks to the drift model and the current model, the link between two different observations of the same identical maps. So now, what do we think about updating or adding the sargassum products in Copernicus Marine Service? We believe that it will enhance the Copernicus Marine Service catalog with high-quality sargassum products that we have been reviewing and improving again these past 2 years. So a different set of products. It will be some monosensors products from ocean color, high resolution, and geostationary radiometric sensors. The final objective would be to achieve these multi-observation products, merging satellite, ocean observation with innovative clustering method. And it will also allow to have this sargassum detection products covering the full tropical Atlantic at once. And for stakeholders, what this will mean, so the sargassum products in Copernicus Marine Service will fill a gap in the actual European offer. There are no data available, operational data available for on sargassum detection actually in the European Copernicus Marine Service. Data is often found and provided by American institutions or universities. And it will enlarge the Copernicus Marine Service user community and attract new users, supporting the international public sector and scientific community, but also stimulating downstream applications and private sector. And to conclude, we have started to share the historical Sargassum projects with the scientific community through a project which started in January 2024, supported by the CNES and under the Space Climate Observatory Program. We are working with IRD and Mercator to produce seasonal forecast of the Sargassum based on this operational daily detection. And my last slide, just to give you a nice picture, and thank you for your attention.
Thank you very much, Marion. So this was the last talk of this session on the main results from service evolution R&D projects. So again, to all attendees, if you have a question, please ask them using the Q&A tab on the main website. They will be answered online. We will try to have a short Q&A session at the end of this session, but in case they will be answered online. So now we will go straight to the next item on Horizon Europe project and their contribution to the evolution of Copernicus Marine. There will be 4 projects presented: Acciberg, Neccton, CoCliCo, and Foccus. And we will start with Laurent. I will give you the control of the slides. And please, Laurent, the floor is yours.
Thank you. So, Laurent Bertino, yeah, I was here yesterday as well from the Lancer Center, and I will present the Acciberg project, which is Horizon Europe EC funded project, Arctic Cross Copernicus forecast products for sea ice and icebergs. So the project has 7 partners, and so over 4 years. And I have the pleasure to be the coordinator, and it's part of the EU Polar Cluster. In short, the motivation of Acciberg is so a rehash of the graphic that I've shown yesterday from Wagner 2020. The operations in the Arctic span very large number of scales, from short scale for tactical response to long-term planning. And the Copernicus services address these scales in different places. And we have the Arctic monitoring and forecasting centers, the global monitoring and forecasting centers from Copernicus Marine Services. They both do provide the short-term forecasts, and the global may be, more adequate for answering extended forecasts. And then there's the seasonal and the climate forecasts that are addressed by the climate change services. So the problem in our case is that it's hard to compare forecasts coming from different services. And a second problem that was also identified, not related to the first one, is that if you're looking for information about icebergs, there's very little information available for free. So that being said, we formulated these goals for our project, that we want to improve the forecast of sea ice in both Copernicus Marine and climate change services, and provide a new iceberg forecasting service. The forecast should be accompanied by uncertainty estimates and be reliable, at least to have a known accuracy. Iceberg forecast should be automated and should become in the future part of Copernicus services. That's our mission. So we have results. The first one that we obtained from ECMWF and the work by Daniel Beaufort is a software package called IceCap. And you see the link here. Is an open source software that allows you to define regions. So here there's a region defined between Greenland and over the Barents Sea, and compare different forecasts from different ensembles. So there's, you heard the name before, Topaz 4 and Topaz 5 systems that were presented by Cyril, and the ECMWF forecast from a recent version. And this is not, here to say which one is good, which one is bad. It's just forecasts presented as an illustration in a given region for one given time period. And you can see how these ensembles look like, and you see how the uncertainties evolve with time and how they start. And if you are interested in comparing which is the best for your purpose, you can just grab this code and start, apply it to, the region and the time that you're interested in. The next slide is about data simulation, which is another aspect that we treat in Acciberg. One of the goals of the Acciberg project is to also avoid loss of information while assimilating passive microwave data, when assimilating CIS concentration. And when we assimilate level 4 data for CIS concentrations, we've already lost, say, the information coming in the 4 different or 8 different passes of the satellite during the day. And also the processing going from brightest temperatures to the geophysical data CIS concentration has also made a lot of assumptions, and we may have lost some information there as well, and put ourselves in more difficult conditions for assimilation because of non-Gaussian nature of the CIS concentration data. So this here is an illustration of an observation operator for 3 different channels of the AMSR2 satellite simulated from the TOPAZ data using one the WENS model for the computation of brightest temperatures. And I can also note that there was a paper by Marina Durand-Moreau from Norway that showed the possibility to assimilate the level 2 data from passive microwave that is in the field of view and at the time of the passage of the satellite. So this is ongoing work since we are only 18 months into the project. The next topic is the iceberg modeling, which is a true cross-Copernicus target. We want to use a framework that is OpenDrift, so an open source Python package that has all of the nice properties that we want. It's in Python, it's containerized, it uses smart subsetting, so it's very efficient, and it's editor friendly. And those of you who follow the editor project may have seen demonstrations using OpenDrift. And Norwegian authorities use it for critical operations, search and rescue, oil spills. The iceberg is, say, a very special case of search and rescue or oil spills because it is a large object subject to some forces from atmosphere, ocean, Coriolis, Stokes drift, etc. And we have implemented these using the Copernicus inputs. So we have winds from ECMWF. We use a log vertical profile because icebergs can stick out 50 meters in height. Ocean currents, wave, radiation, and Stokes drift are 2 different forces that apply to the iceberg, sea ice. And then there's the degradation processes of the iceberg that are very interesting. And these are all coming from Copernicus services in different ways. Now, the concept is to develop an on-demand iceberg that forecast that would be triggered by using an app and going through the ice services. And then users should receive a forecast trajectory on their iPhone when they're in the field. So we are also implementing ensemble of icebergs because the uncertainty is a key issue when providing the forecast, and trying to find accurate metrics to qualify the forecast using kernel density reconstructions. That is, say, the progress on icebergs so far. The main innovations is to have a new product for Copernicus, assimilating level 1 sea ice data, and validating the ice forecast using different Copernicus services. The challenges are that there's very few iceberg trajectories that are available on the desk. So we have DMI, who has been on expeditions in Baffin Bay, who brought us a lot of trajectories. We also have access to old, say, proprietary iceberg data, which are not adequate for the open data policy. And so we are actively looking for more data. Next research priorities, we'd like to have no download operations, everything done on the cloud. And beyond the ice edge, we'd like to also use level 1 data to go to the dynamics of multi-year ice and exploit the new Sentinel missions, the upcoming one, Simmer and Roselle. Simmer for sea ice and Roselle for icebergs. Thank you.
Thank you very much, Laurent, for this very nice overview of the Acciberg project. So now we will go on to the next presentation that will be from Stefano about the Neccton project. So Stefano, I will give you the control of your slides. So please, the floor is yours.
Thank you, Stephanie. Hello, everyone. I'm Stefano Ciavatta and from Mercator Ocean International, and I'm the coordinator of this Horizon Europe project, Neccton, of which I will talk about today. That's it. So the first slide is about why we need this project. But the need of this project is pretty clear. We are all aware how massive emergencies, climate change and anthropic pressures are causing to our environment, marine environment. Few of them, disappearance of Alaska snow crabs because of excessive heating, huge hot blob in the ocean kill millions of seabirds, emergencies for fisheries, and for issues that are not as easy to predict as, okay, hot water is cooking crabs and they die. No, this is happening through very complex trophic dynamics that need complex marine ecosystem models to be predicted and to be managed sustainably. So here we go with the need of this project, which will enable the Copernicus Marine Service to advance its current capacity. The Copernicus Marine Service is already a state-of-the-art for the forecast and of biogeochemistry and low trophic level. Plankton, micronecton are things that are already provided as product. But Neccton will extend this capacity, providing the capability to simulate and to provide products for higher trophic level fishes and marine mammals, for marine pollution stressors like climate change, and for the benthic environment, and also to enable the possibility to perform climate change projections with these prediction models. And this is relevant to the UN Ocean Decade, to which this project has been associated recently, being an endorsed action of the Marine Life 2030 program dealing with the sustainable feed of global population, protect and restore ecosystems and biodiversity, and provide ecosystem-based solutions to climate change. And the few key facts about this project, as I said, it was endorsed recently by the UN Ocean Decade, but it's an Horizon Europe project dedicated to the Copernicus Marine Service evolution. And myself, I'm the coordinator. The project will last through for 4 years. It started in January 2023 and will end 2026. The budget is 10 million and the partners are 23, which are shown in the logos on the right. Okay, let's go a little bit more into detail. What is the approach that we are adopting this project? So it's a three-pronged approach. The first is a conceptual innovation, where we will really aim with our ecosystem models to really represent the complexity of marine ecosystems, looking at the two-way feedbacks, for example, from ocean physics to biogeochemistry, and from biogeochemistry to the higher trophic levels. So really interconnected models. And to do and develop and better make use of these models, we will really try to fuse, to merge observations and models by means of machine learning techniques that will be used to better parameterize the models, but also to improve the current data simulation methods. And third prong, to really use and develop an interlinked modeling framework based on the framework for aquatic biogeochemical modeling, FABAM, in which we will be able to share all our biogeochemical models, our developments, our ecosystem models developed in the project for transfer then to the Copernicus Marine Service. And what we are going to develop in this project then will be tested in climate change projections and in case studies. And this with the final aim to develop new marine ecosystem models and products for the Copernicus Marine Service portfolio. Here it's the list of the 27 Neccton model products subdivided in pelagic biogeochemistry, benthic, Neccton, and stressors, which will be developed for the marine forecasting centers that are represented on the right. So we are going to develop new products like zooplankton for the pelagic or micronecton improved, benthic, clams, Neccton, anchovies, tuna, and stressors, combined climate change stressors, just to make few examples. And we will use observations to calibrate and validate our models also by means of artificial intelligence approaches. We will provide hindcast 44 subset that will be made freely available for users to be easily downloaded through a portal based on the My Ocean View that is the one of the Copernicus Marine service. And these stressors and these products will be tested and evaluated in 13 case studies that we are creating with stakeholders ranging from marine protected area managers to FAO, from the Pacific community to UCN, and 13 case studies that will focus on the conservation of biodiversity and the sustainable fisheries of management, so that we are aiming also to enlarge the range of stakeholders that the Copernicus Marine Service can actually reach. And the products, the models, and whatever we do is co-developed with a large range of stakeholders that we are contacting through dedicated workshops, surveys, and a wide network of collaborations that we are having internationally with Ocean Predict, Embon Goose, EMODNet, just to mention a few, and with a network of Horizon Europe projects that are ongoing and with which we are collaborating, BioEco-Ocean, Edito, Marco Polo, just to mention a few of them. And I think that we are the opportunity to enlarge really globally and to a new network of collaborations through our recent endorsement by the Ocean UN Decade and the Marine Life 2030 program. I think that this was the last slide, and with the possibility to use the QR to get more information about this project, I'm giving back to you, Stéphanie, the floor.
Thank you very much, Stefano, for this very nice overview of the Neccton project. So now we will go to the next presentation by Gonéri about the CoCliCo project. And Gonéri, I will give you the slide control. So the floor is yours, please.
Thank you. Thank you for your invitation. So I'm Gonéri Le Cozanet. I'm working at the French Geological Survey, BRGM, and I'm going to present this project, CoCliCo, Coastal Climate Core Service, which is led with 17 partners, including Mercator Ocean. So CoCliCo is about sea level rise risks. And so we have to acknowledge that compared to other impacts of climate change, sea level rise is a very particular impact, because when we stabilize climate change, temperature, heavy precipitation will stop to increase, but sea level will continue to rise for centuries. And the warmer the climate, the quicker sea level will be. So here you have projections from the IPCC, which include sea level projections depending on different, let's say, global warming levels, and including also the possibility for an ice sheet collapse in Antarctica, leading to 1.5 meters or more in 2100, and of course much more after that. So we're just at the beginning of this, and we're just starting to see the first impact of climate change, but these on coastal area, but these sea level rise risks are about to emerge, and we know that coastal flooding will increase. This is a big challenge that this project is trying to address. So what is CoCliCo? So CoCliCo is the objective is to improve decision making on coastal risk management and adaptation by establishing an integrated core service dedicated to coastal adaptation to sea level rise. And to do so, we work with three different pillars. So the first one is about interacting with users around three decision-making problems: how to apply the flood directive and how useful are broad-scale assessment at national or European scale. The second one is about adaptation in cities and towns. And the third one is about critical infrastructure at the coast, like energy or ports. This is the first pillar. At the other side of the spectrum, you can see the production of new data, of state-of-the-art data on climate change, so sea level projections, including subsidence. We benefit from the European Ground Motion Service, including surges and waves, coastal hazards, so flooding and erosion, vulnerability and exposure of the population, of economic assets and infrastructures, and adaptation option, because adaptation has a large impact on the actual magnitude of risks that we will have on the coast. And between these two pillars, we have the production of a web platform which will deliver the service to users. And the idea is really to have an open access platform which allows users to work with the data, to understand what are the data, and to work with their own data together with CoCliCo's data. So this platform is developed by our partners from NERSC. And of course, we are wondering about the exploitation of this platform. And this is why Mercator Ocean is part of this consortium. And we are thinking about exploitation within Copernicus. Next slide. I clicked once and it didn't work, sorry. So I'm trying to skip the slide. Here it is. So just an example of a result. So here in red, you can see the coastal floodplain. So basically the area which are below high tide plus 1 meter of sea level rise or plus a centennial event. And in black, you have the impact of a marine flooding event. If we assume there were no protection, in practice there are protection, but we assume no protection here. And of course, the area which are flooded are much smaller because flooding occurs just at high tide. So there is not an infinite amount of water which is available for flooding. So this is an example of what we can do with advanced modeling approaches. Slide. So the CoCliCo platform, the project implementation is between 2021 and 2025. So we are developing the platform, we are collecting the data. We think that there is a large market potential for downstream coastal services based on this platform, in particular for public policy support, where to invest in adaptation, for the insurance industry, how to calculate premise, basically how to suggest adaptation measures for their clients. The platform is going to be made available to external partners probably in the fall this year. Oh, I'm sorry. Okay. And the innovation of this project, I would say, if you look at the existing platforms, basically what you see are areas which are below high tide sea levels, but in practice, this area will not be necessarily flooded. It will depend on adaptation options. If we implement protection measures, like an estuarine barrier here in the Thames River, this area won't be flooded. If we implement nature-based solutions, probably the wetlands will grow and the area will be less flooded too. So the innovation in our project is to consider explicitly adaptation in a schematic way, but still in a way that makes sense for stakeholders to assess what could be the impact of their adaptation measures. Now about the exploitation. So we are considering several options for the exploitation of CoCliCo. Our preferred one would be to integrate CoCliCo within the Copernicus Coastal Hub as a pre-service. But there are other options like an integration in the European digital twin of the ocean, so EU DTO, and other options are considered. We are working on these exploitation scenarios with our colleagues from Mercator Ocean. And of course, the demonstration with user in 2025 will be critical to move forward after this platform, which is intended to reach a technology readiness level of 6. And the ambition here is, of course, to move toward 9. Thank you for your attention.
Thank you very much, Gonéri, for this very nice overview of the CoCliCo project. So now we will move to the next presentation, which will be by Joanna for the Foccus project. And Joanna, I will give you the control of the slides. It should work for you now.
Yes, thank you, Stephanie. I'm Joanna Staneva from Centrum Heron. And I have the pleasure to coordinate the Foccus project, namely forecasting and observing the open to coastal ocean for Copernicus users. This is a new project. This started this year in January, and this is 3 years project. And Okay, so it was a bit quick. Our Foccus project has a holistic approach with interdisciplinary team, including observations, hydrology, modeling, but also communications, policy, data management. Foccus Consortium consists of 19 partners from 11 countries, and also we are working with GRC on hydrology, and the scientific coordination is shared between Angelique Mellet from Mercator, Giovanni from CMCC, and me, and Heron is coordinating the project. What is our motivation of the Foccus project? The coastal zones, they are most heavily used and impacted areas of the global ocean. Thanks to a large concentration of the human populations inhabiting the coastal zones, there are a high number of the human activities taking place, and this results in a human pressure and the different anthropogenic stressors. In addition to that, the coastal areas are particularly vulnerable to the existing threat of the climate change. As we have seen already, Europe has a good capacity for operational and systematic information for the global ocean and the regional seas through the Copernicus Marine service. However, still the use of the Earth observation data for coastal monitoring and forecasting is not explored sufficiently, and still efforts are needed to reinforce the coastal capabilities. But those efforts are needed to innovate the related marine knowledge value chain toward the seamless delivery of the different coastal applications into the information product. And here is why the Foccus project is timely and comes with its main goal to improve and advance the coastal dimension of the Copernicus Marine services, but also to demonstrate the coupling between the Copernicus Marine services and the member states services. This will be demonstrated through the implementation and co-design and co-product between the member state services and the Copernicus. And our ambitions is based on the novel development, federation, and exploitation of the co-design and co-develop within the 5 objectives. The first one is on improving the pan-European coastal observations in order to respond to the society and the EU policies. In such a way, the Foccus is contributing to improve the retrievals of the high-resolution coastal data, which are grouped in 4 sectors, namely climate, operational services, ocean health, ecosystem, and coastal challenge. The second one is on improving the land coast open ocean interfaces, and built on the existing pan-European hydrology model, Foccus develops pan-European setup of hydrology, which use not only river runoff, but also nitrogen, phosphorus, particulate organic matter. And in addition to that, implementing the estuary box model. And within these objectives, we are also working closely with the GRC. Then the third one is on enhancing or establishing the connections between the Copernicus services, which are regional, and the existing national coastal services, which includes better representation of land-to-sea continuum, using novel approaches like machine learning, ensemble approaches, and stochastic simulations. After that, we will demonstrate the usefulness of this through the different co-applications. And then finally, we want to maximize the uptake and the impact through the different communications, disseminations, engagement activities with stakeholders, and so on. And then this is based on the enhanced extension of the modeling services towards the seamless approaches. And our ambitions lies in the seamless monitoring and forecasting in the ocean by applying and improving the different methods to develop the coastal products, which are co-developed and co-designed between the member states and the Copernicus services within the three main pillars. The first one is the observations and hydrology. Then we are going to the integrated models and applications, to integrated Copernicus and member states coastal systems and coastal products. And to do that, we are ambitious in terms of having a 3-year lump sum projects, aiming to improve the coastal variables and also to create new high-resolution coastal products which use the artificial intelligence for both the in situ and remote sensing. We are advancing the framework for the land-ocean continuum by including the input of the river and the biogeochemical components. Then further, we are developing novel seamless methods and approaches for the coastal pan-European forecasting with the full production ocean chain. And then we co-design and co-develop the different applications which will demonstrate the added value of the this chain from the observations, land ocean continuum hydrology and Gaussian model. And of course, last but not least, these are the different communication activities with Copernicus, member states, and variety of user groups for the applications. In such a way that our expected outcomes are manifold. This includes the enhanced quality and efficiency of the services, coastal services, which are aiming to respond to the policy needs and the users and stakeholder needs, but also aiming to respond to the different technology developments for the both space, satellite, and remote sensing observations, but also in terms of the novel in situ observations, to develop the efficiency of the new product change, and also to develop the new algorithms and processing the chain. And in such way, our methodology includes 2 phases, which are the design and then implementation phase, going from observations, hydrology, and models to the different applications that have blue economy, coastal protections, but also hazards and extremes. And then finally, these are the uptake from the Copernicus services as well as to the member state services. And we have close connections with the Copernicus Marine. This is through the evolution and the service evolution programs, but it also includes to the coastal hub, and all these new satellite products will be integrated within the Copernicus, and we will aiming to have the seamless connections between the member states and Copernicus services, and of course, close connections through the Copernicus Coastal Thematic Hub. You have heard about that also yesterday. And finally, we have also networking and connections with European and international programs. The products will be integrated into the European Digital Twin Editor, and also we are networking with the UN Ocean Decade, namely COSPREDICT, but also D2 programs. Our products and outcomes are relevant to the European Mission Program, but also Ocean Predict and the Blue Growth. So thank you very much, and then follow us in the social media, and the website is to come soon. It's a very new project.
Thank you very much, Joanna, for this very nice overview of the Foccus project. So this will close this session on Horizon Europe projects and their contribution to the evolution of Copernicus Marine. So now I will leave the floor to the last presentation of this morning. Then afterwards we will have some words from our advisory committee. But now it's a pleasure to introduce my colleague, Yann Drillet, and he will present ocean modeling capabilities in the European DTO. Please, Yann.
Okay, thank you very much, Stéphanie. So, yes, I will present briefly what is under development in this EU DTO framework. So in EDITO project, and as you can see in previous presentation, there is also a lot of link with several projects funded by Copernicus or by Horizon Europe. So this is also one Horizon Europe project to develop this ocean modeling capability in the framework of Digital Twin Ocean. So yesterday you have also presentation by Marion and introduction also by Zoe about this link between EDITO and European Digital Twin and Copernicus Marine, which is really a strong link and very important for all this development, especially in the future. But right now, I will present briefly what is this project. So it's a 3-year project starting 1 year and a half ago. So we are at the middle of this project with 13 partners from 8 countries. You have here all these partners and with very specific skill on ocean modeling, but also on supercomputing, which is really important for this project. There is also partners that are developing artificial intelligence application and a new model and new software. And of course, a strong link with operational oceanography in the framework of Copernicus, but also at an international level with the UNDK, the Ocean Predict, and so on. And a link with the user application, and we will develop in this project a concrete demonstration of how we can use the model for a dedicated application. So the project is organized with these 8 work packages with 3 main pillars. The first block is for innovation in 2 work packages where we develop new emulators, so based on artificial intelligence and deep learning methods, to emulate new variables, upgrade the resolution, or develop new capability for forecast and so on. There is also 1 work package where mainly we develop new components for the model. We optimize the model for new HPC center, for example, and new configuration that will be used at the end in the final application. In the middle of this schematic view, there is this integration part in 2 work packages. So one really to integrate the core model suite in the same framework, and another work package where we develop this virtual ocean model lab. I will just present later what will be the key component in this virtual lab. And then another pillar for user application with a demonstrator for focus application on several topics, and how we can develop also what-if scenario based on this common framework. And then, of course, there is a coordination and communication of the project. And so there is a strong link with the bottom line in this view, which is a European Public Digital Twin Platform, which is really developed in EDITO Infra project with all the components, the cloud infrastructure, the link with the data lake, and so on. So, sorry. So about the virtual ocean model lab, so main objective of this component is really to develop a co-development environment that will be used mainly, and at least at the beginning, for all the model developers, including, of course, the operational center that could be that could also use this type of framework to optimize the production, for example, of the operational forecast or for specific application, and to optimize the way we will use cloud computing, but also HPC. So on this schematic view of this virtual ocean model lab, there is this key element, which is auto-submit, the scheduler, more or less, of all the suite of model, and that will be the key component, especially to connect EDITO Infra with Euro HPC supercomputing platform. So we will use, especially in this project, Barcelona Supercomputing Center and Cineca, which are partners, but objective at the end is also to connect other type of HPC center with our EDITO framework. So then there is also a model builder that are developed also in this framework. So 2 types of model builder. One is SURF that will be used for several types of models, especially for NEMO, but also for unstructured read model. And another one which is dedicated to HBM today, but it's also to provide a diversity of model and diversity of tools. And on top of that, there will be the graphical user interface for the auto-submit scheduler, but also for all the model builder, how we will configure this model configuration using a graphical interface. So that's for the co-development environment for the virtual ocean model lab. And then the tools and the model and the data set that will be available also on the platform will be based on two types of modeling components. So what we call the deep differentiable emulator, which will be a native artificial intelligence building block, and numerical model, so classical numerical model with specific configuration that will be developed. I'll just show you after the list of the model that will be used in this framework. But objective is to go from the global scale to coastal scale with a smooth downscaling and a strong connection with the low mid-traffic level, with geochemistry, with marine ecosystem, and also with model like a pollution or shiprouting model for different type of application. So that's the connection between all this type of model that is really important and key in this framework. So just to illustrate what kind of emulator will be developed in the project. So that's just one example to reconstruct surface velocity and sea surface height based on altimetry observation. And we will also provide a framework to compare and to validate this type of new mapping of the ocean surface, but also how we can provide forecast with this in this framework and comparison with existing Copernicus product, which is in this case really the reference for the validation process and so on. And we will develop also with the same kind of tools Lagrangian drift simulation, especially how we can forecast Lagrangian trajectory, so mapping of SSH, but also other variables, but we will start at least for SSH and turbidity. Sorry, yes, that's the second, the last one. Then there is this long list of models. So I don't plan to describe all of them, of course, but as you can see, there is a strong link with NEMO, as it is done in Copernicus Marine, but we will also integrate new type of model, especially for coastal application or for downscaling, using unstructured grid model and connection between the different grids. So there will be this global high resolution configuration that will be developed by Mercator to produce new simulation and new reference simulation and also forecast. And we will compare with other type of model that will be based on unstructured grid model and with also downscaling capability. And so you can see on the map the different configuration that will be developed all around Europe in complementarity to the global simulation. So in the Med Sea, of course, in the Black Sea and in the North Sea and Baltic Sea. So that's just an illustration of all type of model that will be developed and optimized, especially in this framework in this platform. Then to conclude, just to say that will be also demonstration. So we divided this demonstration in two types. So really the focus application. I don't have time to show you the video, but you can have access to the video. There is a link in this slide, but it is also available on the website. So there will be three thematics for this focus application. One really dedicated to a marine protected area for biodiversity and how we can build mapping habitat suitability in the EDITO platform. Another application for ship routing and how we can optimize travel across the Pacific in this example, for example. And a third example about oil spill modeling and so also providing mapping risk and these kind of things in the platform. And then the second type of demonstration will be what if scenario, with also three type of example. The first one about nature-based solution especially for coastal erosion and how we can integrate seagrass and absorption of energy along wave energy along the coast thanks to seagrass. So we will provide a scenario to really compute and provide a quantify a data set. And then a second one on marine plastic, which is also a different scenario that could be performed on the emission of plastic and so on different type of plastic. And a third example about aquaculture and zero carbon, how we will integrate large-scale aquaculture in different areas and the impact on the carbon cycle. So these three examples will be also available on the platform and will be built on with different model components that will be developed in the project. So we are now in this phase of integrating everything on the platform. That's the objective of this year. And next year we will really demonstrate how it will work and so on. But there will be first a demonstration also next week during this DigitalOcean forum. So please, you can follow this event next week, especially the second day, which will be a high-level event with several short demonstrations about how we can use Edito platform for different, based on different projects, not only Edito. And just if you want to follow also what is done in Edito framework, you can also join us on the different on the website and also on the different network. So thanks a lot, Stéphanie. Okay.
Thank you very much, Yann. So this presentation ends the batch of presentation that we have concerning a project contributing to the future evolution of the Copernicus Marine service. And before ending this session, we would like to leave the floor to two people very important for us, representing our two advisory committee, so our scientific and technical advisory committee, and then our champion user group advisory committee. So I would like now to leave the floor to Neville, please, to give a few words from the stack.
Okay, thanks, Stephanie. I hope you can hear me fine. So good morning, and thank you for the opportunity to speak on behalf of the CMEMS stack. As chair, I can vouch that stack members remain as enthusiastic as they were 10 years ago and feel privileged to be able to contribute as they do. I was not able to join much of the session yesterday, but I know Pierre and then Pierre-Yves gave a good account of what CMEMS has achieved and the strategy for the future. You also heard other presentations, excuse me, which address the topics that lie at the heart of stack interests. We are uniform in agreement that CMEMS and its predecessors have made huge progress, and that from a scientific and technical perspective, the data and data products and model products have greatly improved in all characteristics. CMEMS too has made even more progress. Stack is sometimes almost overwhelmed by the rate and complexity of progress in CMEMS. It is hard for the experts on stack to cover the breadth of the science and technology and the depth required for proper review and assessment. The emergence of machine learning and AI, which you've heard a lot about, is the latest of these challenges. So I'm going to make four points into the first of these. It is essential that this growth and scope and complexity is guided by sound strategy covering the architecture, the science, the technology, and infrastructure. CMEMS as an advisory group cannot do its job effectively if the bigger picture is not well articulated and available for our guidance and for defining the planned pathway. This will become even more challenging as attention shifts to the coastal products and services. We already see many regional interests adding to the complexity in the coastal domain and land coast interfaces. Excuse me again. From a stack perspective, and this is the second point, the extension of CMEMS into co-produced coastal services appears a natural evolution from where we are today. It builds well on naturally and efficiently on a crude knowledge of CMEMS. The success of CMEMS has exceeded all our dreams, well, certainly the dreams I had as a young scientist, and represent world-leading practice for oceanography. It makes sense to build on that. I extend the STAC congratulations to all who have contributed to that success. Staying at a high level, one of the many emerging challenges is in part driven by the rate at which CMEMS is maturing, and that is to keep up with the data and products and make sure they're accessible and usable. The data store is one of the several important steps in achieving this goal. We must recognise that our smarts, including sometimes many levels, versions of a product, etc., can confound or even lead to misuse. As scientists, we love to have the very latest ideas and technology in our operational system and to be updating the operational system regularly to reflect that. It is a balance since many producers, users value consistency and reliability above having the very latest tweak. The Assembly here has discussed the efforts to consolidate data and model processing systems, more standardisation, including in part through the Digital Twin Initiative. And in doing so, CMEMS is more accessible to users and less complex. So to my third point, the push for very leading edge of science and technology must be balanced by the user community ability to exploit and profit from these developments. We should be daring, but not so much that we lose touch with the users. The CMEMS User Advisory Group and its counterparts, the CMEMS User Advisory Group, which we will hear from in a minute, the National Marine Stakeholder Forum and assemblies such as this are all important parts of maintaining the right balance and perspective. And STAC must also play its role in ensuring we get good bang for our buck. For the STAC itself, the most significant contributions include providing an up-to-date strategic R&D plan, providing guidance, review and assessment for CMEMS service evolution. We recently reviewed the first draft of the 14 final reports, which were introduced earlier today. And we also considered and reviewed offers in response to the latest call. The response was excellent. Excuse me. With Karina, we assisted in the establishment and development of the Ocean State Report, and we provide regular feedback and review of TACs and MFCs and achievements on the 3 and 6 year forward plans. Excuse me. Problem with being in Europe. And finally, providing advice and guidance on CMEMS itself. And to the final point, independent assessment and review is critical for ensuring a healthy and competitive CMEMS and contributing to ensuring its component parts, the R&D, the TACs, the MFCs, OSR, etc., are performing optimally. STAC looks forward to the next phase of CMEMS too, and to keeping the science and technology ship steady as Mercator itself goes through a moment of change. Good luck for the future. Thanks very much.
Thank you very much, Neville, for these very kind words. So now I leave the floor to Anna to give some words from the QUAC. Please, Anna.
Well, good morning all. Thank you. First of all, thank you for inviting me here today. It is a pleasure for me to have the opportunity to say some words about it. The first thing, I mean, many of the things that I had written down in order to say today, they have already been said. So I'm not going to repeat myself. But the first thing that I would like to point out is the tremendous effort that the Siemens is doing in the right way for facilitating the life of the users in order to obtain the data and facilitate to facilitate our lives, right? As you have implemented the toolboxes in different programming languages, which is great, and so on. And then there's this translation of the website in order to widen the scope of the users that can be interested on using Copernicus marine data. Nevertheless, I must say that for sure, one of the key milestones that as users that we have is the coastal areas, is something that with the coastal hub is being solved nicely and properly, but we sorry. But there is still a bit of work to be done, but I have just discovered this super resolution data that Aida has mentioned, which is so promising, and that will solve many of the key scientific questions that we ask ourselves when using Copernicus data. However, I believe there's something that we might have to bear in mind when to be implemented or think about it in Siemens, and is that, and I put myself, I'm a scientist and everything that is being done is super promising, but I am an expert user. But what happens with the end users? This is something that from my experience in the with the user uptake and the FPCAP program and so on, we have identified that there's still a gap that needs to be bridged, in the sense that there are loads of potential users that are not technical enough, but they would love to use Copernicus data. They would love to be able to navigate through the website and the data store and so on, but they don't have the exact knowledge or the proper knowledge in order to use that data. For that, I believe that it would be really, and I know that it's been done, all the training and communication products that have been developed, but I think that it would be really nice to have them online, really, like more in depth, so the products. I remember, I mean, right now there's a list of products available, but it's really like a very specific list, very short and with no description. And for some of the users, that what they need is just not that those acronyms or just they just need the identification of what that variable is and what it does. So this is a really small thing, and I believe it would increase the number of users. And so it would be the matter of, and I remember discussing this in the last assembly, the matter of giving a bit more of relevance to the essential climate variables and the use of indicators, because some of the users, and I'm saying this, and I can't believe that I'm saying this as a scientist, but but some of the users, they are not that preoccupied by the range or the exactitude of the accuracy of the data, but they just need to know if the water is fine, or it has some issues, or the coast is being eroded, or I don't know, or if the temperature of is the adequate way, the waves or whatever, because I'm thinking about aquaculture, production, port management, and even like environmental managers that are not, some of the institutions have like a very, very technical skill people, but you find that many of them, they don't. So it's a pity that with such a tremendous, such tremendous effort and amazing data being produced, that is not used by end users. And I said, I'm as a scientist, I'm super happy with it. And I think that it really is. We have come a long way since, I don't know, 20 years ago, that data was delivered in CDs and you had to, to build yourself the libraries in order to read the data or analyze the data. And right now it's being done in an operational way, which is fantastic. But it's a pity that those end users are not fully aware, or they are not fully involved in what the Siemens has to offer them. And I'm sorry, because I extended too much myself. And thank you very much.
Thank you very much, Anna, for these few words from the QUAG. So shall we leave the floor 1 minute to Neville? I don't know if you want to say what you've posted in the chat, because I think maybe it could be very important.
Yeah, I think Anna was just making a very critical point there right at the end. I found exactly the same issue when we reviewed IMOS. There was tremendous enthusiasm in the user community, but just so many were confounded by the almost initial step of getting access to the data and products. And this is despite all the many, many efforts. So I think we on the stack, and of course you, Anna and her group, we just have to seek other ways to lower that barrier, so more people can take advantage of the wonderful material that's available. Thank you.
Okay, thank you very much for these words. So which conclude the sessions. I would like to thank again all the speakers of this session. And now we will go to the coffee break. And during the coffee break, you can still ask some questions through the Q&A facilities, and they will be answered online. So please, we will reconvene in 5 minutes, I think. 6 minutes with the second session of this morning, which is on National Collaboration Program and the Coastal Zone, and it will be moderated by Tina. So see you in 6 minutes.
So welcome back to the Copernicus Marine General Assembly. I hope you had the chance to get yourself a coffee. So we are going to start again this second session of the morning. We are going to be together for the next 1.5 hours. And then I will give the floor back to Cyril for a conclusion. And we are going to close this General Assembly by 1 a.m. In the afternoon. 1 p.m. Sorry. So for this second session, we are going to tackle what we are doing about the National Collaboration Program and the Coastal Zone. So the discussion we had just before were really a very nice transition to this work we are doing together with the member states. So my name is Laurent and I'm working at Mercator Ocean International, involved in the Copernicus Marine Service, and I'm the head of the Market and Service Department. So I have a few slides to share about this National Collaboration Program. So I'm going to give you an overview of the strategy and the implementation of this program that we call the National Collaboration Program. So the idea with this program is really to focus on EU member states and EU contributing states. So in Europe, we have 27 member states and 2 collaborative states. And this program is really to support them with the implementation of the European environmental policies and directives, and really to build together a marine monitoring service, which is going from the open ocean with the Copernicus Marine Service to the coastal zone, which are implemented and monitored by the member states. So it's really a co-design phase, basically, of what could be in the future the open ocean to coastal marine monitoring service. So we are implementing this new program along this Copernicus 2 phase from 2023 to 2028. And we have different call for tender, which are open in different phases. One action is really to reinforce, as I said earlier, the collaboration with the national marine coastal monitoring activities. But we would also like to support transnational collaboration for coastal monitoring activities. For example, 2 member states or 2 contributing states working together in order to implement marine monitoring activities together along the shared coastal area they might have. So in order to steer and help us steer this activity, we have created a new group, which is existing since the last 2 years already, which we call the Copernicus Marine National Stakeholder Forum, which we also call the Marine Forum, which is really the continuity of the Copernicus User Forum, which is implemented by the European Commission DG DFI, where, so at Copernicus User Forum level, we are talking about all the thematic of the Copernicus services, including the marine, but we also talk about the climate, the coastal, the land part, the security and emergency. Here, the aim of this group is really to focus on the marine part and to make this continuity between what we do within Copernicus Marine and the Copernicus User Forum at the European Commission level, and to do this continuity together with the European member states and European contributing states. So this group now includes 19 countries from European member states and European contributing states. So there are Belgium, Bulgaria, Cyprus, Denmark, Estonia, Finland, France, Germany, Italy, Malta, Netherlands, Poland, Portugal, Romania, Spain, Sweden, Iceland, Norway, and the UK. This is a consultative group. We are meeting twice a year. The last meeting took place last May so a few weeks ago, and the next one is going to take place in November. The UK have recently joined because they are back into the Copernicus family. So we are very happy to have UK in our group. We have a new contact point for Spain, and we are really seeking to get contact points and members in our group from Ireland, from Greece, and from Luxembourg, and of course for all the other missing member states. So now I'm going to go more into the details of the call for tender we had in 2023, we have this year, and we are going to have in 25-26, which are part of this program. So let's start with the call for tender we had in 2023. So it was a 1.5 million euro call for tender with projects funded for 18 months, started in July 2023 up to January 2025. So within this call for tender, we had the opportunity, they are still running actually, and we are going to hear more about some of those projects, but we had the opportunity to fund 15 projects over 12 countries within 29 organizations. So you can see on this map the localization in Europe of all those projects. And here is a bit more detail about all the projects we've been funded. So 5 of them were really targeting the Mediterranean Sea, Ocean Basin, and the Black Sea, with 2 projects in the Black Sea. We had 3 projects in the Baltic Sea, and 7 projects in the Atlantic, with 1 which is up north in the Arctic. So those were the localization of the area of expertise and the area of development for all of those 15 projects. So of course, we are more than halfway. We are halfway through the delivery of those projects. So they have already started to deliver their first use case. There is the second use case, which is going to come up. And so the 15 first use cases are now displayed on the web portal. So this is really very good information about what they are doing at national coastal level and how they are linking what they do at coastal level and how they are linking it with the Copernicus Marine Service. So please go to the website and check all those use cases. So what has been implemented? So some of the projects are really improving marine safety. This is a case of the use case 1, 13, and 14. I'm not going to go into details of each of the 15 projects, but in a nutshell, this is really the objective and the application area for those 15 projects. Some of them support biodiversity conservation efforts. Some of them sustain practices like sustainable aquaculture. Some of them enhance disaster preparedness. Some of them, of course, most of them, they support the blue economy sectors, and all of them, they ensure compliance with EU environmental directive. So if we look more in details at which directive they are supporting, so most of them, they support the MSFD, which is the Maritime Strategy Framework Directive, which you see in blue. Some of them also help supporting the Water Framework Directive, which you see in orange, yellow. Some of them also support the OSPAR community that you can see in purple. There is the Maritime Spatial Planning also, which is very important, that you see in blue, the Common Fishery Policy that you see in green, and the Arctic Policy that you see in white. So we are later in the session, we are going to have demonstration presentation of 4 of them. So it's the 4 of them which are in the blue square. And I think there is a mistake for the last one. It should be the Latvian one. And also, we talked earlier about the Digital Ocean Forum, which is going to take place next week in Brussels on June 13. So 2 of those projects are going to be displayed as well during the Digital Ocean Forum, because they are really EDITO and European digital compliant, and they are on the verge of integrating into the European Digital Twin Ocean. So now let's talk about the call for tender we have this year. So we already had 2 call for tender. One was targeting the coastal and the Arctic hubs with use cases. So this call for tender is now closed. We had another one which we called Blue Market Partners, where we were really seeking for networks allowing us to better engage new communities. So this call for tender is also closed, and another one is going to open very soon, and this one is really the continuity of the one we had last year. We are really seeking to continue supporting national activities for the marine coastal monitoring activities. So this is what we did with the call last year. And this year, on top of continuing supporting these national activities, we would like to support transnational collaboration. So we would like to allow 2 or 3 or several member states to work together on their area of expertise or on a new area of expertise in order to develop new downscaling and new coastal marine monitoring activities. So this call for tender will open very soon in June. So this is more information about this call for tender. It's gonna be published in June. The deadline to apply will be in September, and all the projects shall start by December this year. And we are going to be able to find all the information on the Mercator Ocean website, on the tender pages. So now let's talk briefly about what we are going to do in the future. We are going to go on releasing call for tender. So we so far have 3 new call for tender plans. The idea will be to continue supporting national activities as we did in 2023, as we are going to do in 2024. We will continue this activity to continue to support transnational collaboration, and we are really seeking to make the link with the European Digital Twin Ocean. So we will add some more requirements in the call for tender in order really to integrate what is being done within this activity with what is also being done in the European Digital Twin Ocean. So this is it for me, and I would like now to give the floor to my colleague Tina Silovic, and she will introduce you with some of those projects that are started in the framework of this National Collaboration Program. And she will tell you more about that. So Tina, please, the floor is yours.
Thank you, Laurent, for this introduction to a National Collaboration Program and for introducing me too. So I'm going to present you briefly main results from user engagement projects. As you heard from Laurent just now, there is ongoing user engagement project where they needed to build coastal monitoring pilot demonstrations. There were 15 of them, but due to a bit of a limitation of the time, we basically are going to hear just 4 of them that are marked with a green arrow. And also there is a new call for tender similar to this one that is going to be published a bit later this month. So if you want to see a bit more about these projects, you can go to our website, the Copernicus Marine website, and look under use cases, user engagement. There you can see briefly about all 15 projects. As previously mentioned, use cases, there are 15 of them. So we reached first milestone of this program, and the next use cases, the next 15 of them are going to be published in July. I encourage all of you, we are going to soon publish the news about the National Collaboration Program Day. Basically, we are going to have all 15 projects presenting themselves on 16th of September. And now I give a floor to four project leaders from this user engagement ongoing projects to represent their projects. So the first one is going to be Tomasz Dabrowski from Marine Institute in Ireland, and I give the floor to Thomas.
Thank you, Tina. I cannot start my video. It says it's blocked by the host.
Let me see. We can.
Give me 1 second. Should be okay now. Yes. Hello. Your slides.
Do you have a control of the slides, Thomas?
All right. Yeah. Sorry. Yes. So good morning, everyone. My name is Tomasz Dabrowski. I work with the Marine Institute in Ireland, and I will present today the developments in Biodiver Coast project, in which we are developing a service to support oyster aquaculture and biodiversity restoration or oyster restoration in Galway Bay in Ireland. So the project in a nutshell, starting from Galway Bay, it is located on the west coast of Ireland. It's under the influence of tides, wind, and we also have significant freshwater discharges into the bay. And aquaculture sites are mostly located in the southeast of the bay. You can see the polygons marked on the map. And those locations experience quite frequent low salinity events. And low salinity is a major threat to oyster farming and also to the health of wild populations. So here you can see two contrasting images. On the left, we have a low salinity event. And on the right, we have conditions that are closer to normal, I suppose, with high salinity and freshwater plumes confined really to the vicinity of rivers only. And as I said, low salinity is a major concern for oyster farming, and it's also a health risk for wild oysters in the bay. And native oysters in the bay were once abundant, but they have declined in recent decades for various factors. So in Biodiver Coast project, we are developing a service that aims to support sustainable mariculture, also to support biodiversity restoration of native oysters in the bay. And the service will also support policy and policy implementation. And we have two use cases that we are delivering here. One is mapping marine conditions in the bay, and the second one is a warning system for low salinity events. So the consortium is ourselves, the Marine Institute. We are a state agency in Ireland. And the second partner is a company, No Login, from Spain. And they are developers of operational downstream coastal monitoring and forecasting services. And we are co-developing the service together with our end users, which are mainly an environmental NGO operating locally in Galway Bay, And we also have the end users from the Environmental Protection Agency in Ireland, and they are mostly interested here on the Water Framework Directive reporting and OSPAR actions. So they are more here on the policy side. So what Copernicus products we use and the coastal model we use. So at the core of the service is a high resolution model of Inner Galway Bay, which is a downscaled model from the Connemara model, which is downscaled from the Northeast Atlantic model. You can see them marked on the map. This is our operational forecasting service that we operate in the Marine Institute, and is based on the ROMS model. And the Northeast Atlantic model is downscaled from the global Copernicus model. And in the service that we are developing, we are also bringing in any observations that we operationally run in Galway Bay. So the Galway Bay model itself, it's a 70-meter resolution. It's a ROMS model, and it has 8 sigma levels, and it's a very local model of Inner Galway Bay. In the service, we also use a wave model. We operate a wave model as well. It covers the Midwest coast of Ireland, and it is a downscaled model from a Northeast Atlantic wave model, which extends to the whole area presented on the figure. And this Northeast Atlantic model is forced by the Copernicus global wave model. So moving on, this is how the actual service looks. It's a web-based service. So when the user opens the application, which is called NAUI, the user is presented with this sort of map. All the stations that you see on the map in Galway Bay were defined by our end users, and they include aquaculture farms, they include WFD monitoring sites, they include outfall sites, some of the beaches as well around Galway Bay, and several other locations of interest. And the users can plot by clicking on any point. The users are presented with the graph that you can see on the right of the slide. It's basically a synopsis of the forecast for the next 3 days, where users can display surface and floor temperature, salinity, and currents. And the colors on the map represent, it's a traffic light system. So the green color means there is no concern. The yellow color means there is a slight concern with the value of either temperature, currents, or salinity. And the red color means the values are of high concern. And then the users can access also the time series by clicking on one of the icons. So this is an example for the salinity. They can switch between seafloor and sea surface salinity. They can also zoom in and zoom out in time, and they can see how the variable evolves over time. And if there was maybe an event, like a low salinity event, that would be of concern. And the users also have access to about 3,500 pre-cooked images, maps of different variables, and they can display the likes of climatologies, long-term climatologies, seasonal, monthly climatologies, anomalies, and different percentiles as well. So just a few facts about the NAUI service itself. It's quite a mature technology. It's also ready for co-designing with the end users. It's highly customizable. It's interoperable as well, and it can be easily evolved, integrated, and scaled up, and also applied to other locations as well. So just to summarize the 2 use cases, in use case 1, we are mapping marine conditions in the bay. It's based on a 10-year hindcast of the model, and the users were interested in 4 different variables, and they are salinity, temperature, shear stress. They come from the hydrodynamic ROMS model, and they were also interested in wave kinetic energy at the seabed, so the energy exerted on the seabed from the waves. And as I said, we delivered multi-year climatologies, annual climatologies, seasonal, monthly, and so on. And with those images, the users can explore in the past what conditions existed in the bay, what are the statistics, you know, how frequent are low salinity events, how frequent are high temperature events, where are the locations with high stress at the seabed, and so on. And also based on this information, we were able to plot total mortality of oysters in the bay, which you can see on the figure here. So close to the coastal locations where the colors get darker, it means that the mortality increases, and it's due to excessive heat that may be present there in the summer months and due to low salinity, low salinities coming from the rivers as well. And the second use case is a low salinity warning system. It's still under development, due to be delivered shortly in the next few weeks. So basically the users will be able to, in NAUI, they'll be able to plot a time series of salinity to explore the past, and also as regards the forecast, they will be having access to the traffic light system, so they'll be able to see actually not only for salinity, but also for temperature and currents as well. But just focusing on salinity, they'll be able to see over the next 3 days what is the minimum salinity at the surface and at the seabed at a selected location. And if the salinity is of concern, for example, dropping too low, they'll be presented with yellow or red colors. And the last slide I have is the time series from the 10-year hindcast. So on the middle panel, you can see the time series of salinity at one of the farms in the bay. And I marked two quite significant low salinity events on the map. And you can see at the bottom panel how it impacted mortality of oysters. So you can see the spikes in mortality coinciding with those low salinity events. And finally, I would just like to acknowledge 3 funding streams. The first one is the Forecast Horizon 2020 project, which funded the development of the Galway Bay model itself. Then the Government of Ireland that fund ongoing operations of the Galway Bay model, and the user innovation call, the Copernicus user innovation call that funded the development of the service and the Biodiver Coast project. Thank you very much.
Thank you, Thomas, for your presentation. So now we are going to proceed with our next presenter, which is Jovita, an engineer from Klaipėda University. Jovita, I think you can take control of the slides.
Thank you, Tina, for the introduction. Yeah, it's working. So today I will present about the operational model for the Groningen Lagoon and Southeastern Baltic Sea. So we are moving to the Baltic Sea now. Shortly, I will say about the main tasks of our project. So the project aims to improve the understanding of the shallow lagoon and coastal waters of Lithuania. Mostly in this project, we are focusing on our largest European lagoon, Groningen Lagoon, and the shallow areas of the Baltic Sea around Lithuanian area. And with this project, we also aim to promote an operational modeling services for the stakeholders and enhance the visibility of the CMEMS and Copernicus, all the Copernicus services. So I would like shortly to present our institute, because I really believe that it's the first time you have a presentation from Klaipėda University. Our Marine Research Institute conducts international marine research, supports R&D projects. We shape marine R&D strategies and participate in the educational processes as well. In the institute, we have 4 laboratories, so for fisheries, aquaculture, coast and environmental biogeochemistry, water transport and air pollution, mechanical and marine engineering laboratories. In this project, we are quite small modular group working on the development of the project. So my colleagues Rasa, Georg, and Petras are involved. We are all modelers and developing this modeling system. So really shortly about model and the products we use for our service. So we are working with the SHI-FEM model. It's a shallow water hydrodynamic finite element model. As you see, this is a computational grid of our model, and it really covers the southeastern coast of the Baltic Sea. In the circle map, you can see the basin and where the water comes from which area to our lagoon. The grid is with triangular elements, and in the really active hydrodynamic areas, it is about 20-50 meters, and in the middle of the lagoon and in the coast of the Baltic Sea, it can be up to 1 kilometer or 1.5 kilometer, and on the corner on the boundary of the sea, it goes up to 5 kilometers. It is a 3D model with the vertical zeta layers, and you can see on the slide how it is divided. So about the forcing data. So first, we use Copernicus Marine product for the Baltic Sea physics analysis and forecast model. So we take the salinity, water level, and water temperature data from this model for our sea boundary. Then we use meteorological data from European Center for Medium Range Water Forecasts. So all the meteorological data is taken from this operational model. And we also get the river data from the Lithuanian Hydrometeorological Service to force our model from the river discharges. And very shortly, what we are doing. So the aim was to downscale the Copernicus model, and why this idea came to our institute. It came mostly from the stakeholders. Just because you can see the resolution of the Baltic analysis and forecast model in the CMMs. So the resolution of the CMMs in black, and the red line shows the coastline, the real coastline. And this central area is a harbor area, which is very hydrodynamic, and it's the only one outlet of the system from the lagoon, where the resolution and the precision was very important. So we suggested this project for a better development of this coast. And what you can see now in the picture, how the resolution of the harbor looks now in our model, it's really much higher resolution, and especially in the shallow and narrow areas. The main parameters what were model, excuse me. So wow, sorry, water level, salinity, water temperature, waves, and currents. And what we offer two use cases for our services. So the first service is dedicated for the operational planning of the monitoring activities in the coastal area of the Baltic Sea. All the maps and the forecasts are available in our website dedicated for this project. And this task and this service came from the Lithuanian Environmental Protection Agency, who were really interested in the organizing the monitoring activities due to the forecast. And the second use case is still ongoing, and we are still developing it, and it will be for the monitoring of the spills or chemical or microbiological pollution in the area. And you already can see an example of one oil spill event we just had in February. So we already tested this approach and get the results for our environmental protection agency. So going next, as I mentioned in the first slide, that we really aimed to be close with our stakeholders, and stakeholder involvement was very important for us. So now we are working with 3 main groups. So it's Environmental Protection Agency, Lithuanian Hydrometeorological Service, and Klaipėda State Seaport Authority. They are really interested in the development of these services, and we are working in the small groups. We have meetings and really trying to make the service more suitable for them. And in the beginning, we all the time show the Copernicus services, what they already have, what you already have, and what they can find. And then we discuss how our service can help them in their daily life. And as I mentioned, our results are accessible and free of charge through an online web page. And I think that's it for my side. So I really thank the. I think it's not my side. I not switch the slides, and thank you.
Thank you, Aida, for the presentation. Now we are going to go to the next speaker. And the next speaker is Mada Rodriguez. Marta, I think
now I can see the content. Thank you, Tina. Good morning, everyone. My name is Marta Rodrigues. I am a researcher at the Portuguese National Laboratory for Civil Engineering, and I am the project leader of the Connect project that aims to provide a local coastal monitoring service for Portugal. So let me give you an overview of the project. So Connect delivers a local high-resolution coastal monitoring service that seamlessly integrates model-based forecasts and observations to provide physical and biogeochemical data on Portuguese estuaries. The service is demonstrated by 2 use cases, 2 Portuguese estuaries, aiming to support the implementation of the European environmental directives, and in particular to support the evaluation of the ecological status of the estuaries, also to quantify the land inputs to the adjacent coastal waters, and to support the anticipation of inundation events in these areas. So regarding the consortium, the project has 2 partners. So the Portuguese National Laboratory for Civil Engineering is the project leader, and we are mainly responsible for the model forecasts. LNEC coordinates the U-Best Coastal Observatory, and we also coordinate the Water Information and Forecasting Framework and the Open Coast On Demand Forecast Services. Then the other partner is the Faculty of Sciences of the University of Lisbon. They are responsible for the near real-time in situ observations. They are the coordinators of the CoastNet research infrastructure, which is an observation network that is also part of the Danubius research infrastructure. So let me now show you a little more detail about the coastal models and the regions where we are implementing the service. So we are downscaling the IB regional models from CMEMS. We are downscaling physics and biogeochemistry, and we are using the outputs of those models to set the boundary conditions for the local models. And as I mentioned, we have two use cases, the Tagus estuary that you can see in the bottom, and the Mondego estuary that you can see in the top. They are located here in the coast of Portugal. And the local models are based on unstructured grids, so they have higher resolution than the regional models. Near the coast, near the shoreline, the resolution is about 100 meters or less, and inside the estuaries it can go down to 3 to 5 meters. And the vertical resolution, vertical grids are based on hybrid grids, and they also have higher resolution than the ones from the regional models, because we are in shallow areas. So let me now go into some more details about the coastal service. So the Connect Coastal Service integrates high resolution operational modeling from the estuary to the coast, and including circulation and water quality. It also includes near real-time in situ observations and Earth observation data. It has a WebGIS portal where the users can access the physical and biogeochemical forecasts and observations, and it has a seamless integration with the Copernicus Marine service products. So here in this slide, you can see the architecture of the service. The blue part of the image is the core of the backend of the service. So there are several external sources of information that provide mostly the boundary conditions. Then we have the coastal forecasts that are powered by the Water Information and Forecasting Framework and the Open Coast Service that run the SKIS numerical model. We also have some input from the rivers, and then all this information is processed and made available in the WebGIS portal. And there are different layers of information, including maps, time series, statistics, and also some summarized reports. Here you can see an example of the products and of the results that we are generating for one of the use cases, the Tagus estuary. So we have implemented two models here, a 2D barotropic model that includes the waves and currents interaction, and it is mostly dedicated for the anticipation of the inundation. You can see that in the upstream area of the estuary, it has the grid covers all the areas that can be flooded. And then we have a 3D baroclinic model that couples hydrodynamics and biogeochemistry. This model is more devoted to the water quality issues, and it produces results of water levels, velocity, salinity, temperature, inorganic nutrients, dissolved oxygen, and chlorophyll A. And then we have the in situ monitoring network that has 3 stations located inside the estuary, and where several physical and biogeochemical data is also being measured. One important part of the project is that we aim that the service really fits the user's needs. So the service is being developed together with the users. and we had several dedicated actions with them. At the beginning of the project, we addressed their requirements for such type of coastal service. And at this stage, we are receiving their feedback on the coastal service, on what other features they would like to have in the coastal service, to see how we can really improve the coastal service to fit their needs. So finally, I would like to show you just one image of one of the outputs that we are producing in the WebGIS portal. So this is one of the dashboards of the portal. The Today dashboard summarizes some of the available information for the day of today. So in the left, we have a map with the forecasts, and the user can navigate in this map. It is also possible, if you can see the dots, for the user to see the values that are measured in the in-situ stations and compare those values with the model forecasts. And we are including also other existing sources of open data besides the COSNET monitoring network. And then in the left, the user can see the time series of the variables in these stations and compare again the model forecasts with measured values. There are other dashboards that give more synthesized information. In particular, the indicators dashboard gives information about some of the indicators that are used by the Portuguese Environmental Agency to implement the Water Framework Directive. So that was it from my side. Thank you so much for your attention.
Thank you, Marta, for your presentation. Now we are reaching the last presentation for the user engagement program, and that would be Till Rasmussen. I'll give you the floor.
Yes, thank you. Let me see if I have control. Maybe I don't. Can I change the slides?
Yes.
No, there they are. No. Oh, good. Thank you. That was one too many. I will present the use case of Disco Bay, located in Greenland, and it's a service developed by DMI. My colleagues are listed down here. They are doing most of the technical work right now. But yeah. First of all, the motivation for working around Greenland as part of the Danish kingdom. And in Greenland, you don't have any roads, so you need to have alternative ways of transporting goods around. And the waterways are one of the best alternatives. The only complication is that sea ice is often present, not always. And that is a great hazard as well as icebergs. And in general, it's not just traveling of goods. There are also many tourist cruises coming in these regions to look at the beautiful views of Greenland. And you have many fisheries around which support the economy. And all of these require information about the ocean, the weather, the sea ice, and how these behave when they're trying to plan how to get into a port, for instance, like the ship in the image here. Yes, so this is a one company consortium, the Danish Meteorological Institute, which I represent. We are also responsible for weather information in Greenland. And we host the Greenlandic Ice Service, which is also one of the use cases. I'll get back to that. And we have the responsibility to provide all of these information for the users so that they can stay safe at sea, and also to support the Navy with information about security, about the same topics in order to keep the security around Greenland. and that is not becoming a smaller issue these days. So for these reasons, near coastal fjord system information is crucial. And this service, combined with the manual ice charts and the current informations that originate from the Arctic MFs or the Copernicus systems, are all valid and useful for this. So the service itself, DU aim at providing a 750-meter resolution for the Disco Bay area. What you see here, that's the AIS tracks, and it can clearly be seen that the greenish colors, that is where most ships move around. AIS tracks, they show or indicate ship locations with a given time intervals, and it is especially the southwestern part of Greenland which is busy. The Disco Bay area is ice-free in summer, partly ice-covered in winter. We have a high-resolution forecast from the weather system, but this service will expand this to include a physical forecast of the ocean and sea ice in the area. And it's based on the HICOM sea ice model system. I'll not go into too many details about, but it's at least the physical part of it looks like the Copernicus Arctic MFC system. And to set up this regional coastal service, we are using the Copernicus systems. We're using observations for assimilation, and that's the lower part here, where the new automated sea ice product that Frode talked about yesterday can be, one swath of this can be seen here. And the model domain is the gray box around approximately. And then on the upper plot, you can see the Arc MFC from the viewer. And one of the gains of having these regional coastal models is that you can resolve the bathymetry, the topography much better. And that is a general, it's just a matter of the resolution you can run your small systems compared to the higher the coarser systems. And at the same time, the outer ice conditions here, that's from OSISAF. And again, passive microwave have some issues in the near coastal areas with land spillover, and therefore it's important for us to have this automated sea ice product together with the ice charts that also originate from the Copernicus system. And as a feedback to that system, the ice charting service at DMI has promised to create daily maps of the region, which is higher than normal. And we also have some wishes for future developments of these observations and boundary conditions. So higher frequent hourly for the 3D fields. I know it's a lot of data, but that would be really nice. And we would also like to see the level 2 grid product from remotely sensed observations. So just some feedbacks on what a wish could be, and the latter part is if you want to resolve ice conditions at less than a kilometer, as the ice service want to, and you grid your data for a day, then it's hard to keep up the accuracy in the resolution. So instead, we would like to we aim at assimilating level 2 data into the system. So the first use case that we will look at, that's the ice service. The reason why we use an internal use case is that they have the connection. They talk to all our users once a year. They at designated meetings. They have designated meetings with the piloting service that is mandatory for ships above 250 people, and they are the ones. So they act as a service provider, experienced service provider for many of these users, in order to tell them which data products should they use from the Copernicus or other sources. And this means they point to satellite images, they point to ice charts, they point to model forecast, whatever the ice service think is relevant for a certain use case. At the same time, they are also producing input for the model system, and these two are the sort of the root of data. It starts with a Sentinel-1 image, which is turned into either an ice chart or an automated ice chart, and then this is included into the model system, and then the model system feeds back to the ice chart, and they will send data or services to, for instance, the Royal Arctic Line or the Navy or others who have the interest in this. So this ice service acts as our link to all the real users out there, but that's why they're important to have involved in this, also in the evaluation of the products. Then the second user, that's on the ecosystems, and it has been shown that the ice cover correlates negatively with the primary production, and therefore it's important to be able to say something about where the ice is in order to model the biology and the ecosystems in the area. And we are collaborating with Aarhus University, who's doing the ecosystem modeling on providing these forecasts to them in order to feed their models. And at the same time, there's also a negative correlation in the area with the salinity. And Aarhus University this is less dominant, Aarhus University have tried to use the different large-scale model systems there are, and they find that the resolution in the in fjord systems like this are on the low side if you use the large-scale systems. And again, therefore, they are very interested in using this high-resolution model. We are also talking as a side to this use case to Greenlandic institutes, who are also doing a lot of measurements and of both biology and water properties in the area, and we are also discussing with them on how to provide the best possible output from this system in order to help them as much as we can with the short-term forecast of ocean and sea ice in the area. And I think that was what I had. Thank you for your attention.
Thank you, Theo, for your presentation. And I thank once again all the project leaders that presented their projects within our national collaboration program. And I invite you all to keep an eye on our on the Mercator Ocean International tender web page, where you can track our new call for the same program. And also save the date for 16th of September, where you can hear other projects introduce themselves and their projects. And I'll give the floor back to Laurence.
Thank you very much, Tina, for this very nice overview of the 15 projects, at least 4 of them that presented today from Ireland, from Lithuania, from Portugal, and from Denmark. There is more use cases to come. There is another batch of 15 use cases that will be published soon. So in September, indeed, the workshop with the presentation of all the 15 projects is going to be very interesting. Now I would like to give the floor to Muriel Lux, that is going to chair a roundtable with the member of the Marine Forum. So we are very happy to have, as I said, 19 EU member states and collaborative states participating to this Marine Forum, which is really helping us to steer our national collaboration program. So we would like to hear from them, and Muriel is going to chair this roundtable. I would like also to remind you that next week, the Digital Ocean Forum event is going to take place in Brussels, and some of our projects are going to be showcased, including the one from Thomas and the one from Tia that you just showed. They will be presented in a different way, so I encourage you to attend virtually this meeting that is going to take place as a hybrid event. So without any waiting further, I would like to leave the floor to Muriel for this roundtable around the Marine Forum. Thank you.
Good morning, everyone. So we arrive at the last but not least session of this General Assembly. It's my pleasure to animate this roundtable with some of the member state representatives at the Marine Forum. So Laurent already reminded us what the Marine Forum is. So just quickly, I would like to remember again that it was created in October 2022. We have already met 4 times, and we count now 19 members. As Laurence mentioned, we have still some countries missing. So this is a call for the countries that are not represented in the Marine Forum to join us. So what is the Marine Forum? This is a consultative instance to foster interaction with member state representative in the marine domain. And the idea is to collect feedback and needs to provide information about the Copernicus Marine Service and the different event and call for tender. And this collection of feedback is very necessary so that we improve the link between the national activities and what the Copernicus Marine Service provide to these national activities. So I'm very happy to call at this board Gada El Serafi, representing Netherlands, Carolina Sa from representing the Portugal, and Andrea Taramelli representing Italy. So we couldn't invite all the 19 countries because of a time constraint, but next time we will have some other countries available, I hope. So Gada, Carolina, and Andrea, if you want to open your camera. It's done. It's done. Oh, okay, I didn't see. Hello. So, maybe we should start by a short introduction of yourself, if you agree. So, Gada, if you want to start.
Okay, thank you, Miguel. So my name is Gada Serafi, and I'm a specialist in data science and coastal expert in MultiRes, and I'm representing the Netherlands, and I'm very happy to be part of this panel. Very short.
Nice, thank you. Carolina Sa, if you want to introduce yourself, please.
Hi, hello, good morning, and thank you very much for the invitation. So I'm Carolina Sa. I'm the EO project officer of the Portuguese Space Agency. My background is marine science. I have a PhD in marine science and a specialist in ocean color. And I'm the delegate at the Copernicus User Forum, and I'm here also at the Marine Forum representing Portugal. And usually I'm present with other experts in the meetings. Thank you.
Thank you. Andrea, it's your turn now to introduce yourself, please.
So thanks for the invitation to all Mercator. My name is Andrea Taramelli. I'm the Italian national delegate to the Copernicus User Forum and Copernicus Committee. My background is geophysics, and I'm a full professor at High University School in Pavia.
Okay, thank you. So now, if you agree, I would have some questions to each of you. First, I would like that you, if you can provide your feedback about the Marine Forum concept and its usefulness. For us, it's important to know if we have to improve it or modify the concept of the Marine Forum. What kind of feedback would you have, and how you think we could improve it? So Gada, if you want to start.
Yes, I would like to start, and maybe I would like also to say, well, for us in the Netherlands, it was a very useful connection to what we are doing, and a very useful connection to be able to link to the Copernicus to our national forecasting systems and monitoring. Would like to maybe highlight a little bit the comments of Anna before our session. Which is actually the link to the users, etc. This is a very important thing, and I think the national project is a very nice way forward. And I think with these presentations that we have before our panel discussion has proven to reach out to the users and to provide the information needed in the way that is needed, and in the resolution and frequency that is required by users. So I think it's one way forward to link to a user somehow, and also to link to our national obligation for reporting and for monitoring and for other things, given our role in the Netherlands, for example.
Thank you, Gada. Very, yes, effectively, the link to users and stakeholders in each country is very important, and the objective of all of us is to reach the user and to make the service useful. Thank you. Carolina, would you like to express your feedback regarding the Marine Forum concept and its usefulness, please?
Yeah, thank you. And I think our comments are very much in line with the Netherlands. So for us, I think this is very valuable because during the general user forum, there is not much time for in-depth discussions on specific service, just from time to time, as you know, a rotative way. So for us, it's really important to have a forum, a specific forum to discuss the specificities of this service. And also to discuss not only just get information on updates, regular updates on CMEMS and activities, but also how we can integrate our ongoing national activities. So it's very good that we can bring experts from the different member states to have these discussions. And maybe my comment for improvement would be maybe we should focus on this last item that I mentioned on the discussions. So how can we maybe involve more our national stakeholders, and how can we promote more transnational discussions? So I think that many countries we know that face same challenges, and learning from each other is really an efficient way to uptake and to learn. So maybe these kind of activities could be done through specific thematic workshops, but also by just including a slot of presentations, for instance, of successful national use cases could be a easy way to start this exchange. So reserving a slot in the meetings for national presentations where people can exchange and learn a bit from each other. I think that could be an easy way to start these interactions or improve these interactions. And also on our side, I have to say that we still also need to work on our networks and how to coordinate better our national networks to have an efficient way of consulting them, to provide feedback, and also to better disseminate information. So I think it's not just on your side, but also on our side to improve. Thank you.
Okay, thank you. Thank you, Carolina. Thank you so much. It seems to me, before asking the question to Andrea, that Gada, you wanted to ask a comment?
Yes, to add a comment. So just comment on improving. I think we are not done yet. Let me put it that way. There are plenty of other things that we have to take into account, and I think the call for tenders that upcoming, which is working on the transnational activities and learning from each other. This is an excellent way forward. So I think we have just started, and what we can do is to improve from both sides, as Anna have mentioned, the feedback from the users in our national community towards Copernicus, what is being used, and the other way around. For the transnational, that has to actually happen across border and not only that, for regional collaboration. So if we are talking about reporting, if we are in the North Sea, that means that is not only the Netherlands is really obliged to report, it's also the Belgium and the German and the UK, etc. So I think it would be a very natural way forward to do this kind of collaboration across nations. So I'm just highlighting that there should be not only tenders, but also this communication among experts for enhancing this transnational collaboration.
Thank you, Gada. Actually, you anticipate a bit my next question, but we will come back again after the feedback from Andrea Taramelli and Italy for the same question. Your feedback regarding the user, the Marine Forum concept, please.
So as Italy, you already know that we were a lot of pushing for creating this dedicated forum, and so for us it's a very valuable instrument, and we do think that as Carolina was saying, having this dedicated forum allow member states to have a more deepened and fruitful discussion, specifically focused on specific thematic services. In this line, what is still, not missing, but can be really improved is the link with the national user forum. We do think this is one of the most important things because, as we always stress, it's important when we talk about operation. So when we go about operational services, there are, a different way of, let's say, classifying the end users. Specifically, Carolina was saying that also member state has to do their job. So we have done quite a lot in creating what is the National User Forum and a dedicated table to coastal and ocean thematic discussion. But we have always stressed that we have to be really clear on what is an intermediate users and a very final users. So this is something that still has to be discussed, because if we mix up this, then you can have an improvement of the services that is led by just the intermediate users. While as Italy, we are always stressing that it's really important to have clear who is the final end user and who is developing the services with the European level. We do think this is something that we still have to improve. And this is linked to what both Carolina and Gada were saying. It's important to have a transnational discussion, because this is really important, because maybe different approach can be discovered in different member states. And the other thing that is really important is that mixing up what is an end user and intermediate users can bring to an evolution of the operational services that is not going to be used by national institutions and so on. So we do think that this kind of link with the National User Forum is really important to improve. And I think this is going to be discussing the other question, but we do think this is really important. And for us is super optimal to have a user forum dedicated to the coastal and ocean, to this operation. So it's a very positive, answer.
Thank you, Andrea, to underline this really importance of this national mapping of stakeholders and the final users that we would like to focus on. So, but what do you mean by a national user forum? You mean having a discussion country by country, or to try to organize something transnational, having these final users all together to express needs? Have you an idea to reach them?
This could be an option to organize some, session of uptake and discussion between different, national user forums, so that they can, in the user forum that you are building up, you have a representative, but then you cannot have every community. So having this interaction also with the national user forum can bring, a value added. This is an option that we stimulate. The national collaboration program, but we will discuss later, can be an option, but then we have to build on the top of that.
Maybe if I can highlight what I was mentioning in the end. So maybe we can start this discussion also in the Marine Forum, like having a slot where we can have a thematic topic that all member states can bring their experts to discuss a bit these transnational opportunities. So maybe using the forum that we already have established and having specific slots for thematic discussions, because we cannot bring to the forum all the experts. So if we have a thematic topic, then we can bring those experts to those discussions. And that could be an easy way maybe to start and then going from there. Thank you.
Sorry, I lose my mouse. Thank you so much for this comment, and it is well noted. I think that thematic discussion could be a first way to organize a time slot in the Marine Forum. Now, maybe I would like to have some subsidiary question, but very linked to what we just discussed regarding the national collaboration program. We mentioned that it's good to have this transnational collaboration possible to foster interaction of between countries, especially the cross-border countries. What so far regarding what already exists through this national collaboration program, what are the benefits so far you can testimony? Maybe we can start with Gada.
Can you repeat the question, please?
Oh, sorry, I was not so clear. The current national collaboration program we have, it is divided in several call for tenders, and so far, what kind of comment or testimony you can have on this, and how we could co-design them better?
Yeah. So sorry. I was still thinking actually of the stakeholder engagement of the comments before, so that's why I was trying to switch to another question. So maybe it is related to the discussion that we had before. I think it is the national forum is very good because you have one person responsible to convey the information from one side to the other, which is really great, and it's also allowing us to discuss what is needed from our perspective within being the delegation of the country from our national obligation. So this is really great. However, we still have this point that has been raised by Andrea and Carolina, actually, the stakeholder and a wider user group. And I think one of the things that we have discussed the last one in May, that we have maybe to activate this feedback from the user community in our countries. So to have like a workshop organized together with Copernicus into our own countries, that we can reach out to all of the stakeholders, because we do have this list of stakeholders and interested parties. And that would make it a little bit strong, and then we can interchange this concept of what is the users at the downstream service level is one thing from one country, and what the intermediate users are able to provide, and with the Copernicus on the other side to capture the requirements needed to improve or to evolve the services. So that would be one way forward, I think. We have proposed that already, at least the Netherlands, we were talking about that, and we proposed that maybe it would be one nice thing to organize a joint workshop for stakeholder engagement in that way. So I think that is one way. I mean, every country is having its own ways of doing things, and having this national conversation at the Marine Forum, that would be, you learn from each other and you capture what is the sense, and maybe to harmonize activities maybe together and jointly if you are talking about regional workshops. That is also, so you can also organize regional workshops for stakeholders at large, not only, so country, that is one, within the country is one, regional within the region is another one, then you are activating the transnational activities, and then maybe a wider one that is the General Assembly, maybe that is Mercator field, I would say. So testimony, I think it is working. It is still not done, and we still have to do plenty of other things. The tender is one way forward, and there are other things to be done and discussed. So thank you.
Thank you. Thank you. Do you want Carolina or Andrea add something about this?
Maybe if I may, just to say that the National Collaboration Program was very welcomed from our community. There were a lot of interest. People participated a lot. So we've just seen one of the projects that were approved in the previous panel. And we believe that these kind of programs will help evolve the national services and will be a great support for the implementation of the environmental directives, as we also seen that the projects are involving directly end users. So this is very important. We also see that these projects is a way of guaranteeing that evolution of CMEMS includes the national capabilities. So we've seen before that coastal in-situ monitoring is being used. So this can be uptaken by CMEMS, and all the regional needs are also considered. So this is also a clear benefit from us. Of course, this program is still starting, and it will be important to understand what will be the long-term impact and how it will be possible to keep supporting these national teams, and how will these projects be integrated in a transbordery context. So we very much recognize the value of these programs, and we are looking forward for the next call on the transboundary and the discussions and evolutions of the program.
Okay, thank you, Carolina. Andrea, do you want to have a last word, because we are reaching the end of our session?
Yes, I will be fast in that. So we agree that National Collaboration Program is something that is really valuable. As Carolina was saying, as a member state, we are stressing also at the user forum and the committee that there's need of guarantee the continuation of that, because involving national end users is a long road, and needs to be constant and also in the funding rate in times. What I would like to add is the fact that in the National Collaboration Program there are, for us, two very important things: is the feedback from member state for the evolution of the services, but also it's really important to keep the goal of really making the services known by end user on a technical level. There's a lot of still gap that has to be really filled, that we need to really still train at national level what the marine service can already deliver, because trust us, at national level, there's still a huge community that don't know almost anything about the marine services and so on. And this, can be applicable to all the services. So there's a really need now to spend a lot of time with the community at national level to train them, because most of the time they replicate what is already available from the European level. And this is really important. That's need funding to do that. So the National Collaboration Program, it's a key part. And again, I can just close on what Carolina was saying. It's important to do it in a transnational way, because there's no boundary between layers in the coastal areas in the sea, and that's really important.
Thank you, all of three. Well, this is the end of this session. Thank you so much for your participation. It was really appreciated. Now I will give the floor to Pierre-Yves Letraon for the closing remarks and discussion. Thank you so much. Bye.
Take off camera.
Thank you, Muriel, and thanks for the very good discussion for this very important national collaboration program that we have. So we are entering the final session of the General Assembly, which will first very briefly discuss our post 2024 perspective. So if you can, Vincent, show the slide. And then I will conclude with some word, for the closing of this General Assembly. So Vincent, I cannot control the... Okay, it's okay. Okay, so just to remind, the objective that I presented at the opening of this General Assembly. So we have a clear plan, which is aligned with the EU Green Deal and digital strategy. So where we want to remain a marine reference worldwide and to implement new capabilities that are driven by user and policy needs and fully take into account science and technology advance. So we ensure the continuity of service. We make sure that we embrace the new capability of digital services and in a synergy with the digital twin ocean, and preparing the implementation of next generation ocean and sea ice monitoring forecasting service systems and new services for coastal with member state and biology that we were just discussing previously in the roundtable. So, in a summary of the achievements that were reviewed during this General Assembly, first, in terms of user uptake, we are quite satisfied with this increasing number of subscribers and the number of visits that we have, single visits that we have on our website every year is really impressive. So this is really quite satisfactory, but we want, of course, to continue to progress on this. We have now this reinforced governance with the Marine User Forum that we just discussed during the roundtable, which is an essential element for us to make sure that we evolve the service according to member state needs. We have been operational. Important to remind that the Copernicus Marine Service has been operational since 2014, so 10 years, but also be able to manage continuous improvement. This major evolution of the Marine Data Store, also linked with the digital twin ocean that we presented several times during this General Assembly. Our activity on the links with the policy, with Ocean State Report, with the full, a reorganization of the Ocean State Report with a new journal and a new editorial board. Our activity with the coastal zone, so starting this coastal extension of the service in interaction with member states, developing coastal and Arctic thematic hub, on the important element with the National Collaboration Program. We are working quite hard, to understand user and policy needs and to gather user feedback. So this was presented several times during this General Assembly, how we manage this process of interaction with user, and then how we work on future evolution, on service evolution, taking into account, these user needs, on addressing all research and development activities with the different streams of research and development that we have. I think this operational service and continuous improvement is really a key element of the Copernicus service. I think it's important to remind here that we work with the production centers. On those production centers, sorry, I have a problem with the delay. Those production centers are really providing an operational service, but in parallel, they continuously improve their products. So over the past couple of years, we have had 5 releases of portfolio with many improvements in our products. I mean, that's on that were detailed during the General Assembly. And we really have a well-organized process, which is the transition from research to operation, which is well in place. In addition, we have all the user support on user service activities that really makes this important building block of a user-driven service. We have this new marine data stores, the new toolbox. Again, a major improvement in the way we can better serve users. I will not repeat this again, but this is showing how we evolve not only in terms of product, but also in terms of tools and services for the user. Last but not least, good example also on the capabilities that we have developed over the past couple of years is all the capabilities that were developed with the viewer, with the MyOcean viewer, that allow to visualize all the different products that we have, but more, I mean, just also to extract and download data sets. So, looking into the future, I mean, on what are our plans for the post-2024? So, we will renew all our production centers contract by the end of this year, and we'll start in 2025 a new phase of the Copernicus Marine 2 up to mid-2028. So in this phase, we want to continue evolving the Copernicus Marine in response to user and policy needs. We have developed a series of priorities. So one of them is to strengthen our national collaboration program, to continue working with the other services. So we had a nice roundtable discussing how we interact with C3S, CEMS, and also CAMS on CO2 monitoring, on ocean climate, and also serving emergency management needs, and also with Emonet, with a key partner for in situ observation. Synergy with EU Digital Twin Oceans, this was repeated many times. This is really key for us to have this convergence between Copernicus Marine and the new tools and new services that the DTO will provide. On the longer run, we'll have also to prepare the uptake of future Sentinel expansion missions that will really provide, I mean, really new capabilities, in particular to better observe, monitor, and forecast the Arctic Ocean, and prepare post-28 service evolution. So this was presented this morning. So all the activities through Horizon Europe on the mission ocean. More specifically, I mean, that's, and I will not detail this much, but we have really the plan that we have in terms of improving the offer is based on all our service evolution strategy. Just to mention, because we had very good examples this morning, so we will infuse more and more artificial intelligence techniques in the service that we provide, but also improve with new observation on new models, on new coupling methods. We will progressively implement an ensemble forecast service line. So this is something that we consider in response to user need to better describe the uncertainties related to model forecast. Evolution of marine data store, a key aspect that we plan is to develop the use of the EU Digital Twin Ocean platform edited by the Copernicus Marine Production Center. Consolidation of observation impact assessment is also key to us. I mean, we interact with the Copernicus satellite and in situ component, and we have to make sure that we communicate all the needs that we have for observation that are really the pillar of the services that we provide. And we will, of course, continue implementing the coastal extension of the service with member states through the National Collaboration Program on research and development activity, in particular with the Foccus Horizon Europe project. Similarly, the plan is to implement progressively new biology product. So during this time frame, also on the longer run, in interaction with the Neccton Horizon Europe project that was presented this morning as well. Last point before closing is also reminding that we are not alone in Europe. So we are working at international level. International collaboration and impact is essential to the Copernicus Marine. So we want really to align our effort toward the ocean we want and to contribute to the UN Decade 2030 vision. So Copernicus Marine contributes to almost most of the outcomes of the challenges of the UN Decade of Ocean Science that I will repeat here, but we contribute to many of its programs and projects. We have direct link with the Ocean Prediction DCC, but it's really very essential for us to be embedded in this international landscape, because that's really essential to progress in the way we can monitor and predict the ocean. So as a conclusion, in a few words, our post-2024 plans, so we want to build on our past achievement to continue evolving Copernicus Marine product and service offer. We want to maintain a world-leading and state-of-the-art marine service responsive to user and policy needs. And we also will prepare post-2028 activities on new challenges for a safe, protected, and sustainable ocean. So this closes my short presentation on our post-2024 objectives. So I think it's now time to really close this General Assembly. Just a few words, I would share with you before closing. First, with a big thanks to all speakers, participants to the roundtable. Particular also thanks to all Copernicus Marine service contractors, so for production center, thematic assembly center, monitoring and forecasting center, marine data store, service evolution project, national collaboration program. Big thanks for their really commitment to develop the Copernicus Marine service. It's really essential to have this large European networks of experts contributing to the service. A particular thanks for this General Assembly to Vincent for managing so well as usual all this online event. We rely a lot of on Vincent on this. This is very well, very professionally organized. So thanks again, Vincent, for your work for this. This event has been highly successful. We have had actually almost 1,000 different participants to the online event from more than 100 countries. And actually, this is, in terms of number of participants for an online event for Copernicus Marine, this is a record. It's good for our 10th years anniversary for the Copernicus Marine. We have several questions on what we will do next. So all presentations will be soon available on the event website. We will also make sure that we provide written answer to the questions we received during the General Assembly. So all participants will be informed by email when this is available. It will be very soon. Important to stress here that the high success that we had in this event is really a strong motivation for all of us here at Mercator, but also on behalf of all our contractors in Copernicus Marine to continue evolving the Copernicus Marine as a really a fit-for-purpose, impactful state-of-the-art marine service. So last, as explained, I just explained, so we'll start early next year a new phase of Copernicus Marine 2 for the period 25, mid-28. Our next major event will be a high-level opening in February 2025. So stay tuned for more information on this event. Meanwhile, as noted by Laurent as well, there is this very important event next week on the Digital Ocean Forum in Brussels. And you are very warmly encouraged to follow this event online, because there will be a lot of connection and synergy with the Copernicus Marine on Emonet, of course. So again, thanks a lot for your participation. I'm looking forward to our future interaction. Thanks a lot.